inaugural ceremony of MSc Postgraduate Diploma in Sustainable Process Engineering 2023 in K. So first of all, I warmly welcome the chief guest and the keynote speaker for this ceremony, Senior Professor Ajit Alvis, Dean Faculty of Engineering, Dean Faculty of Graduate Studies, University of Moratuwa, and then our guest of honors, Mr. Sanjeeva Chief Executive Officer, Inaugural Lanka Private Limited, Mr. Priyanjit Pereira, Chief Operating Officer, Phoenix Industries Private Limited, Mr. Inaugural Head of Manufacturing, Unilever Sri Lanka Private Limited, and Professor Shamda, Head of the Department of Chemical and Process Engineering, and professors at the Chemical and Process Engineering Department, Professor Shamda Singha, Professor P.G. Rathnasiri, Professor M. Narayana, and also I warmly welcome all the students, MSc students, or I would rather mention them as MSc candidates, because you all are engineers and professionals working in the industry. I warmly welcome you all 2023 in Tech for this inaugural ceremony and the commencement of Master of Science and Postgraduate Diploma in Sustainable Process Engineering. So I hope that today we will have some good experience and some sharing of knowledge from some of the expertise available here. So while inviting you to enjoy the rest of the session, thank you very much.
Thank you, sir. The Department of Chemical and Process Engineering, University of Moratuwa, is the largest department that produces chemical and process engineers in Sri Lanka. This invitation is to you, Madam Professor Shanti Godage, Head of the Department of Chemical and Process Engineering, University of Moratuwa, to address the gathering.
Good morning, everyone. The keynote speaker, Professor Alvis, the Dean Faculty of Graduate Studies, Mr. Priyanjit Pereira, the Chief Operating Officer at Phoenix Industries, and Mr. Sanjeeva Chulakumara, Chief Executive Officer at Environment Sri Lanka, Mr. Inaugural, Head of Manufacturing at Phoenix Industries, Unilever Sri Lanka, and my dear colleagues and your lecturer panel, Professor Shamda Singha, Professor Rathnasiri, and Professor Narayana, and the new faces that will join today to our department. Welcome you all. And it's my great pleasure to address you as the head of the Department of Chemical and Process Engineering. And this department conducts two postgraduate programs, but not now. There's a new addition also. It's a collaborative one called USL, it's a new economy one. And there was a one called Polymer Technology, and it was stopped for some time, but again this year we are going to start that program. And this is the continuously and successfully operated program throughout 15, maybe over 15 years. This study program was commenced in 2007 under the name of MSc or Postgraduate Diploma in Sustainable Process Development, and it's a collaboration with the Telemark University College in Norway, and later that university named as University of Southern Norway. Under the Norwegian Agency of Development Cooperation or a program for Master Studies project that is called NOMA project, and that was funded by the Norwegian Center for International Cooperation in Higher Education. And this program was initiated by Professor Rathnasiri and his PhD supervisor in the Telemark University, Norway. This Nova program aimed in transferring experience on environmental and industrial projects from Telemark University, Norway to University of Moratuwa, Sri Lanka. Professor Ratnasiri's supervisor, late Professor Moratuwa, was the founder of this program, and Professor Ratnasiri was the first course coordinator. Since 2007, this program was offered for several intakes for about 12 years, and in 2019, the program was restructured and introducing new modules, and the program was initially called as Sustainable Process Development. Now it is changed or converted to Sustainable Process Engineering. You are the third batch of that new program. Then this program normally contains many industrial-oriented learning activities for you to enhance your practical knowledge on applications and professional development, and that provides the opportunities for you to join various supplementary sessions like short courses, webinars, seminars, and these are conducted in collaboration with foreign universities and foreign experts, as well as experts and top managers from the renowned companies in Sri Lanka. You will have a chance and opportunities to do energy audits and some field visits virtually as well as physically to participate during this program. Actually, I am not going to talk about much on the program because my knowledge is very limited to that area. You have experts in this area, and as I mentioned, the lecture panel is in front of you, and I think Professor Narayana will explain and describe what are the new trends in these courses. Actually, I know that there are circular economy and some life cycle assessment concepts tools, those were introduced, but I was not involved in the curriculum change or not in this program. Right? And as I mentioned, there's a well knowledgeable and experienced lecturer panel is with you, and you are lucky to listen to their talks and to learn concepts from them. And I believe that you will enjoy this program, and while staying in our department, and you are joining to our chemical and process engineering family, and I wish you all. Thank you.
Thank you, Madam. MSc PG Diploma in Sustainable Process Engineering is the only postgraduate degree program in Sri Lanka that covers every aspect for a sustainable process industry and offered purely by a Sri Lankan university. We invite Professor M. Narayanan to introduce the course curriculum and brief course outlines.
The description regarding the master program. Actually, this MSc and PG diploma, we are calling it that's a capital to get. That means they are only considered up to the production level. Then that's up to we are considered we are not care about that what happened to later that our products or anything. Then then we convert to trigger trade. That means then our product need to be that means disposal. That means disposal because of remaining things happening, a lot of issues. Then now the present situation is we need to go further. We have to recycle that, reconsuming that. That means the concept is critical. Here there is the raw material extraction as well as the new raw material need to be formed again. There are no any waste removed to the world like that. That concept presently we are following. The reason is that there is a social responsibility. Now that's called the sustainable system. Because of sustainability, we are remaining forever for our material, energy, and everything. There's a concept of sustainability. Now, this is the main concept we are following to develop our program. Then that's the reason sustainable engineering. That means processing, manufacturing, and as well as the end user. Then if we are considering this all as well as the recycling also. Then after recycling, then later on with the raw material extraction. Then all this area we are going to cover under this program. Okay. Now here there's a brief classification of subject area under our main frame. This is theoretical knowledge. We need to learn first. What are the fundamental like all those things? You can see the process engineering principle, the process safety. Those are the key areas, the environmental biotechnology, the circular economy, process analysis, and all those areas is a fundamental already incorporated in this course. Then after that, on top of that, practical skill also. There are a lot of practical skills you can gain from here. That means like that, there's the energy auditing, as well as a lot of field visit we are going to plan with you. Maybe we can gain some practical experience as well as how this process is conducted in the real process flow. Then those are the practical experience and issues and problems in the real world manufacturing process systems. As well as ultimately the last one, the practical. There is a project of also there. There's one of the compulsory one for to operate in master level. Need to be project work like that. Because of that is we are going to gain some qualification. The framework they need to complete research component. Then the ultimate project work. There's a two area. There are two subject areas. So one is that is special study project. As well as the research work is there. Then after the semester, all your course after completion of your all coursework need to follow one research topic. When we go to mapping, when we go to develop this course, those are the mapping areas under flag of the sustainable process engineering. Now I already explained that what is sustainability. Because of that, these things need to be recovered without damaging our environment. We can survive this forever. Then those are the mapping under the course, process analysis, sustainable process design, chemical engineering principles under that. Those are the main areas. You can see that there's an environmental, energy, and sustainability management, research and development, safety, and these all design areas are there. These are all subject areas may cover all these main categories. Then you can see here all this subject area is connected with sustainable process engineering. Yeah. Now, This outcome of our course, here, those are the entry qualifications. I hope you already have some idea about what are the entry qualifications. Basically, this is a master level degree. Then your entry qualification basic degree need to be required. Then there are some categories. If it is engineering degree or it is a 3-year science degree, need some experience to come here. As there are several paths. There are many paths as an entry requirement. Then after entry requirement, there are some few exit points also there. Actually, it's an achievement. You can see here. And the one actually you can end up with the PG diploma. The meaning of the PG diploma without research work, that will be helpful to your career, maybe all fundamental and all theoretical areas are already covered under that without that research part. Then that part is there. Then if you complete that research part, there are some openings. Maybe there are some openings to entry qualification for further studies like PhD or some other higher degrees in maybe foreign country opportunities. That's another part. As well as your career development, maybe the career promotions and everything also may be required at master level. Those are the options of these graduations. That is the qualification. There are 3 parts are there. Now, I am going to explain very in detail regarding this all subjects in semester wise. Basically, we have 3 semesters, and ultimately you can see the master dissertation is there. You can see the semester 1 we have the environmental management, environmental biology, sustainable process, industry and chemical principles. In the first semester, basically we are going to cover this all required fundamental what we are going to use in the next semester 1 and 2. Semester B and semester 2 and 3. Semester 2 again this applications level 1, process analysis and mapping, process safety and risk management, sustainable process development techniques, engineering research techniques. These subjects are covered in the semester 2. Then the key concept I already explained previously is the sustainable under the sustainable process. The semester 3 is a sustainable process design, air pollution control. This ultimately now we are talking about what are the outcome of this master, the sustainable supply chain management, process modeling and circulation. This optimization tools also there somewhat because optimization will be very much vital one in the present day, maybe energy as well as the quality in all need to be optimized, the environmental emissions and all those things. And the process other than special study. There's a key link to there's a special study in after semester 3. However, that can be linked to your final research work. Those are the main subject areas. You can see the credit numbers also given here. In the altogether, the total credit number is 20. There's the requirement for the master level degree. Then here, there's a continuous assessment and a final exam like that. There's a 14% we assess you by using continuous assessment. Maybe the quizzes or the teamwork, maybe there are many matters we are going to assess the continuously. This project work, the self-learning matters and all we are going to use that as a continuous assessment. And the final, the summative exam is conducting. This contribution of these subjects 40% and 60%. Then here, at this semester, I'll give very quickly this thing what I just saw on the subject content. The title is energy management. Those are the learning outcomes. That learning outcomes mean after completing this subject, you should be able to do these things. That you can see that there's an energy efficiency and they're able to analyze energy systems and they're able to the most effective energy saving methods they can understand. The key there's a key outline is here. This is more practical way than those other subject outlines. In a global combustion based, there's a steam generation. Most of the fundamental we are going to cover under that energy management subject. There's an environmental bioeconomy is one of the subject here. Then you can see here that the principle of there's a lot of fundamental principle of the biological base for treatment, principle of biological process, the base for treatment, modeling and simulations, and the solid waste management, environmental management and systems. Those are the key syllabus. Those are the outline of this subject. Then after completion of this course, you should be able to do these things. That means you may have a basic understanding of, let's say, environmental as well as the bioprocesses. Then there's sustainable process industry. Here, there's a key infrastructure here based and the planning, development, design, operations, as well as we are going to discuss some case studies also in the context of the practical implementation. Then this is subject to the semester 1, the chemical engineering principles, because of this under the process. Then here, those are the concept of there's a basic concept of chemical engineering principles, the concept of unique processes. There's operations, continuous batch, as well as these things fundamental transport phenomena, maybe a mass balance, heat balance, momentum balance. Then the separation process, the filtering and certifications. Then these things we are covering under this subject. Then in the semester 2, process analysis and mapping. This outline, because learning outcomes are the understanding of the basis of the process map, then understand different application of process maps in the industry, as well as the different type of process and using industry. Here, those are subject area we need to cover under that, as well as the risk, the safety and risk management also one subject is semester 2. Then those are the areas we are undercover that, as well as identification, as a risk terminology and the risk management, all those things, the operating procedure, those things. The sustainable process development is one of the key subjects. Under that, the life cycle assessment, the team productions, in the sustainable and the design of sustainability, and these are the eco designs. We are teaching about we are teaching footprints, then the resource as well as the environmental accounting also there. There's a research techniques, because of the MSc, we have to cover some areas to do the master level. That's the reason we are including this type of subject here. Then what are the, because it will be very much required in some industries, how the research formulation, as a research, the literature review, as well as the ethics in engineering, research, experimental planning, design, as well as very much on data analysis also. We are going to teach here. Semester 3, sustainable process design. There's a process design, there's a sustainable process design, life cycle approach. The previous semester we learned some fundamentals in this more application side. Then those are the manufacturing efficiency and these things. Ultimately, several case studies also. Yet we will going to cover here. Here, there's an application subject. There's the air pollution control. You can see there's a pollution, atmospheric pollution control techniques, and those things we are covering in this subject area. The sustainable supply chain management also very much required in these industries. without the supply chain management, these systems cannot be sustained properly, and supply and demand need to be considered. Then that is the reason those are the sustainable sourcing, green manufacturing, green warehouse, the transportation, everything. The concept as well as some theories also we are going to come under this subject. As well as a process modeling and simulation, then some simulation tool maybe you will learn there. Some tools like MATLAB or some open source tools will learn there for optimization, as well as a modeling concept, how the process can be simulated for understand how it's operating. Like because of optimization, we need to understand that how that process is working. Then that's a special study. This is self. You all should need to complete that special study. Maybe if you're already working, personally working in some industries, you can choose your place and choose one project. Then there's a special study need to be covered. There's a project work. There's a project work. There's totally continuous assessment. IQ assessment is there. This special study can be continued up to the final research work. Those are the main subject areas in the semester 3. Then research work, you all should conduct your individual research work, and we can assign suitable supervisor. You can choose some project, some research work in the industry as well as your related interest field. It's totally dependent on your interest. Okay, I think those are the main concept of our MSc project. Thank you very much.
Thank you, sir. Next, let's pay our attention to see what the past students say about this MSc PG Diploma in Sustainable Process Engineering program.
Is in need of sustainable processes and eco-friendly ways of doing business, transforming innovations, products with reduced energy and environmental footprints that improve the quality of life. With this mission of developing the process industries for a sustainable tomorrow, University of Moratuwa offers the part-time degree program, postgraduate diploma, and Master of Science, Sustainable Process Engineering.
Hello, I'm Tamani. I'm a master student holding the postgraduate diploma in Sustainable Process Engineering at University of Moratuwa, and currently I'm a master student at University of Calgary, Canada. For me, this postgraduate diploma on Sustainable Process Engineering helped me greatly to get the admission to University of Calgary, because the master's program which I'm currently doing is also related to energy and environment. Study areas like energy management, wastewater treatment, air pollution control, life cycle assessment. All of these areas taught in the postgraduate diploma will be very useful to me when I'm doing my master's. Following this course offered at University of Moratuwa will create many opportunities to you, not only for working in the industry but also if you are looking for opportunities to engage in higher studies at prestigious foreign universities.
Hi, I'm Dhanushi. I'm working at Lanka on a global program related to sustainability. I followed the master's course in Sustainable Process Engineering in the last intake. When I was trying to select it between different courses, I was immediately drawn towards this particular course offered by the University of Moratuwa, especially because of the great panel of lecturers who are subject matter experts in specific areas. One other reason was the nature of the course itself. The subjects were very relevant for my current role, and there were several field visits that were planned throughout the course. I should say that field visits were the most exciting part for me. You get to see how you can apply your knowledge to real life problems, and you will eventually connect the dots. All in all, I believe this is a great course, and more than anything else, it has helped to develop the way we approach the problems that we encounter in the industry. I would highly recommend this course to anyone who is interested in the side of sustainability and thinks about the future of the planet.
For me, this is more about enhancing and educating my knowledge, but I learned in academic studies, so how it can be applied on the industrial scale. So even we had several discussions with toilet groups, so these discussions gave us their knowledge and their experience, so we can improve ourselves and our professional career. So I believe this is not only for the chemical laboratory, but also it can be followed by the other disciplines as well, because the theories are much more fundamental and easy to learn.
This is Epsiba, postgraduate diploma student in sustainable process engineering. After completing my bachelor's in chemical engineering from NIT, India, I have worked for nearly 3 years in an industry. During that time, I realized the importance of sustainability and I have enrolled to this course. This course has vast modules including sustainable process techniques, sustainable supply chain management, environmental biotechnology, energy management. After the completion of the course, I got an opportunity to migrate to Germany. Currently, I am working on the research projects related to circular economy, life cycle assessment, sustainable solid waste management. There are vast opportunities in industries and there are more job opportunities and higher PhD opportunities in foreign countries, especially in Europe. So this course not only equipped me with the sustainability knowledge but also gave me a good career path.
I'm after Java started working as a chemical process engineer at the Petroleum Corporation Refinery. Recently, I completed my master's in sustainable process engineering at the University of Moratuwa. Actually, the course was really nice. The content was amazing. That is matched to the modern process engineering world. That also helped me develop my technical skills in my professional career. Please follow this course and have a great experience in your professional career.
I'm Puni Jayasuriya, student of 2021-22 Sustainable Process Engineering MSc. In my career, I'm an environmental specialist for Sri Lanka and Myanmar. And I'm an engineering graduate of Department of Chemical Process Engineering, University of Moratuwa. Although I'm an engineering graduate, I felt the need of having a postgraduate degree to climb up the career ladder. At that time, there were other courses which had shorter durations too, but I knew the quality of the lecture panel and also the modules of this course were very interesting and very relatable to the sustainable field. So this was the best option for me. If you are passionate for sustainable studies and if you are in the manufacturing industry, I can recommend you that this is the best option you can take.
As a person who engaged in the sustainability sector, I would highly recommend this course for the industrial people who are currently working in the sustainability to engage with this program.
Consisting of a timely updated curriculum with carefully designed course settings, enhancing your practical skills with industry-based activities. This program will bring you to the next level as master professionals in sustainable process engineering.
Thank you for your attention. We have reached out to the most important event of this inauguration ceremony. That is keynote speech. The keynote speech will be delivered by Senior Professor Ajit P. Alvis, Dean, Faculty of Graduate Studies, University of Moratuwa. Before that, we invite Dr. M. Ratnayakar to present a short bio about Senior Professor Ajit P. Alvis.
So our keynote speaker for today's session is Senior Professor Ajit Alvis. Let me present a brief bio of Senior Professor Ajit Alvis. Senior Professor Ajit Alvis completed his PhD at University of Cambridge, UK, post completing his BSc degree, BSc Engineering degree at the University of Moratuwa. He also has an MBA from Postgraduate Institute of Management of the University of Sri Lanka. He is the recipient of numerous awards in recognition of his work, most notable being the Senior Molten Medal of Institution of Chemical Engineers UK and Danberg Maxwell Award from University of Cambridge for the best PhD thesis, University of Moratuwa Research Awards from 1997 to 2007. He served as the chairman of Engineering Research Unit of University of Moratuwa from 2005 to 2007. Professor Ajit Diaris was also a postdoctoral research fellow at University of Reading, UK, and visiting scientist in Indian Institute of Science in Bangalore. He has published many research articles and book chapters in various international and local journals. He was also the science team leader for Sri Lanka Institute of Technology, from its inception in 2008 to 2011, and chairman of the National Nanotechnology Committee at NSF from 2011 to 2012. He is also a regular columnist of the Daily FT on science, technology and national development. We enjoy his writing there. He is a member of various local and international professional bodies as well, a huge list. And he served as the project director of the Coordinating Secretariat for Science, Technology and Innovation Sri Lanka since 2013, and currently as the Chief Innovation Officer at the National Innovation Agency in Sri Lanka. At present, he is a Senior Professor at the Department of Chemical and Process Engineering at the University of Moratuwa, and is also the Dean of the Faculty of Graduate Studies, University of Moratuwa. Sir, it's the respectful invitation for you to deliver the keynote speech. Thank you.
Everyone, good morning. Thank you, really, my Dr. Ratnayake for the invitation. Happy to be this our place. So, okay, without just going through, I thought I'll tell a story, right? So you're learning or starting to learn in this program in interesting times, definitely. It's an interesting time for all of us. For one thing, Sri Lanka, we have declared economic bankruptcy, so there are enough challenges. But the point is, how do you face the challenges? Well, do you run away to some other place? Or do you be the pilots of change, right? And I suppose when you're engaging in something like this, that's an opportunity. I always remember the case, I always tell this, that in Korea, the change in Korea was done by 40 scientists. Just 40 scientists after the Korean War, right? It's working on multiple areas, they delivered. Of course, there was support, but it was specifically stated on 40 areas, even few areas, it's by just 40 scientists. Now, technically, you have a group here as well for transformation. So, what I'm showing is the essence of sustainable process development, the masters, and hopefully you will never stop at the PG. You will go to do the research project because it's a project that's very, very important. And project is what comes out of the system, and we have a chance of doing a change. The selection of the project and the engaging in that and delivering a result. So what you see is the world's first net zero Brandix apparel factory in Bangalore. World's first, right? And what do you mean by net zero? So we're talking about sustainability. These are the terms that are coming in. I mean, it's not just words you have to do. And net zero is the most scientifically you have to give it in the sense that this place is not actually as a result of the entire operations. There is a greenhouse gas emission is zero, right? You will be accommodating that whatever you produce, and there is an absorption. It's not carbon neutral in the sense that you can go on emitting the way you want, but you can support a forest somewhere or buy something from somewhere and kind of like balance it. So that's the little old version, which is the carbon neutral. So you go to net zero, and there's of course the opportunity for going net negative as well. Like Bhutan says, Bhutan President Prime Minister says, my country is negative. I mean that I'm not a burden at all, and not only I'm able to take it from someone else's as well. But of course the point is, no Bhutan, no the others. Bhutan will not survive if there's only Bhutan is doing that, right? the time that we just have to do things differently. That's why I said you're learning an interesting time, but maybe you have to act as you learn. Because this 8-year period is going to be so critical. So this is a net zero facility, Sri Lanka. It's world's first. And then go to something, another world's first, but then we did it as well from here, right? I was involved with the team together, but interesting, this is a MAS thoroughly facility. Another, but this was carbon neutral, going with the leads. This is going with the leads product, carbon neutral. This point is going with the product that the approach they were doing, but this went the leads first platinum, world's first platinum apparel factory in the world, and from the ground zero, basically from scratch, the entire plant. So it's a full University of College exercise. And so we had a chance if I do the case study in semester 3. So these are things that you are talking now about this transformation. Why do you want such facilities, right? Remember that when the human being changed from to the Neolithic age, the two things that were important for our progress was one is agriculture, the second was mining. You need both those things, right? But that's our transformation from the caveman to a much more civilized situation of a developed status. So we were transferring from that, and two things, agriculture and mining. But both these operations had to have processes coming out. Food has to be produced and then processed and then distributed, and all that has to be made available. Mining, just mining won't do, they have to be transformed into utility materials that are of value to us. So again, but we still see these two as fundamental to our living, right? Our quality of life per se comes from these two. So the situation is, now having out these things in the traditional way has also now given us problems, right? Now that's where we have to understand. So we see this, come to this is the World Environmental Day, June 5th. If you look at the Moratuwa laboratory, the carbon dioxide calculate, or rather the assessment, which is a famous Keeling curve, and it's interesting that that person was very interested in measuring something as carbon dioxide, which was 0.03% in the time in the 1950s, and so it's interesting that he thought, let me measure this, and he started not only measuring, he developed the technique, and this is the curve that we have with us today to study this phenomenon of global warming. And because he was starting from the very beginning, that he was recording this data, so today we have a curve. But what you see is the value for June 5th, it's 424 ppm. So some of the early science books, or rather even not that early, sometimes some of the science books even today will be talking about 0.03% when it's now not peak. Right? Long gone, this is now 0.04 plus. So at some point we were worried that the climate tipping point will come at 420 ppm. Right now 420 ppm was tipping point. We never know, there are a couple of messages saying we have somewhat little gone beyond the recovery phase as recovery point as well. That's where climate change. That is worrying. But anyway, we have gone past this. So we came to 400 in 2013 July. Right? Slowly and steadily, this is moving up. So you can see it's our activity. Our activities it resulted in this carbon dioxide value going up, or as a result of all the greenhouse gases, this number is going, and the consequences of this number going up is serious. So I don't think that many of us now disagree that this is a problem. Still there are people who disagree, and there are still scientists who disagree. That is also there. And some of the scientists have also some very interesting theories which are very scientific as well, why they do not agree. But today that number is a minority, but they need to be understood as well. Anyway, so this curve, Keeling curve, seems to be on the rise, and that's worrying, right? We all know when the temperature goes up a bit, we can't do anything about it, right? And it's frustrating. Now we have seen villages in Pakistan going up to 50 degrees up. We have seen in Australia some places people are actually living underground in some places. That's the way to sustain our lives in a survival, right? So it's very interesting. Very developed, not so much, but yet developing. Temperatures are going up. We are going for a serious crisis. That's a big issue, right? So that's what I said. It's not about just one country doing something or planting trees and having the forest cover 70%, but there's a lot of changes that we ourselves are doing. But in our quality of life, we have been producing things, and those things sustain us. Or we are happy about those things. So that's why, from a process point, now we need sustainable processes. Because it's processes that deliver all these that what we're talking about. It's always a process that delivers these things, right? But now we have to make that process a sustainable process and make our living a sustainable living. And so that the planet becomes sustainable. Anyway, maybe in the long run may not be everything sustainable, but we don't want to just corrupt the system by our activities without, in a very haphazard way, by acting alone. We should not be disrupting the planet. So that's something we need to take into account. So that's the value. So two things, right? For any process, we're talking about raw materials, and energy. So energy is critical, and that's something again in Sri Lanka we need to understand. So there is this story. It's actually a scientist, Brian, who went on around the US at one point, putting problems that are happening in the society, right? And he put these problems, which are energy, water, food, environment, poverty, terrorism, disease, education, democracy, population, all the stuff, right? Can population be a problem? Is democracy a problem? In a way, democracy may be failed to carry out democracy. Education, the issues of education. If you're not doing it right, that's a problem, right? How to get it right. So one of the things after putting, what the basic thing he identified is everybody lists these problems. And one thing that came out was, if a country has sufficient amount of energy at its disposal, most of these things, or almost all those things, will not be a problem. Because you have this energy to do things. And in a sense, if you look at Sri Lanka, that is something we need to understand. We as Sri Lankans may be having per capita about 75 units, right? But if you take Norway, maybe 25,000 units that a person has access to. Now that's a huge gap, right? So you can look at the energy stats, hopefully that's what I've just new two figures in a different way to say that Sri Lanka, we are energy poverty. We just do not have enough energy. For one thing, if we have a more manufacturing industry policy, now we are seriously looking at getting some industries in, right? The point for Sri Lanka is there's no way out unless we have processing, unless we have manufacturing bringing in. So there is discussion how to get, having delayed so much, hopefully something will happen. But when you look at it, we don't have that energy, right? And even in the agriculture man to industry man, when you see the human being evolution and the per capita energy that people have associated with different ages like agriculture age and industry age and so on, if you look at it, we are still in the agriculture age. Our Sri Lankan energy content, right? We are not in the industry age. So that's a big challenge. So that's a problem. We say regional energy prices, if you take our energy prices to the industry, is quite high, right? And so lack of energy really affects us, and probably last year we saw this in a way: no gas, no electricity, no fuel. What are we going to do? Right? Energy is central. Now the point is to transfer that energy now to a more sustainable process, because we have been depending on that energy in unsustainable or other non-renewable resources. But forgetting renewable or non-renewable, the society transformed itself with energy from these sources. And those who had plenty of access to those energy, they developed their systems, right? And industries were present. Now the challenge is we have to transform this industry to one thing, which is renewable systems, then to sustainable processes. These things are need to be done. For us, not having industries, we may be able to do something from scratch in the better way, or rather the more timely, future fit manner from today itself. So that's an interesting challenge we can do, right? So it's just a point that focus on energy. We need energy. So policy has to be, we need to work on this and to ensure that people have access and the society has this energy to do other things. It's important. So why many of this energy? Yes, this is the example. Now, today you see here in US has broken records. City New York has broken records in the worst air pollution recorded. Right? As we speak, that's the situation in New York. Right? The reason for that is nothing to do with US. It's to do with Canadian wildfires. Right? And each part. Now we have seen that again. When Delhi has the season for the agricultural refuse and starting replanting the next time, pollution is in Sri Lanka as well. Of course, the Delhi pollution is much higher, but some of that we get into the Sri Lanka as well. And we had animal deaths, and remember last time we had sudden deaths of animals and so on. It's the certain atmospheric conditions, air circulation, and Bay of Bengal has to do something with the low pressure to trigger that to get pollution to Sri Lanka, but now it's coming because as a result of climate change, Bay of Bengal is also not a very, it's a little bit more dynamic than usual. So that's something. So understand that we are facing this, and mind you, as a result of this, certain number of people are going to meet an untimely death. Because as per the WHO, the number one killer is air pollution in non-communicable diseases, right? Non-NCD is air pollution. And the number one environmental problem is climate change. So it's very interesting. Both are in a sense atmospheric, right? So this comes from our pollution, comes from because of the energy use. So the societies have been propelled forward by energy, but the type of energy that we have been using has given us an even bigger problem of climate change. So now we have to reverse this or do something serious, right? So that's the challenge. That's why this process is important, but learning is not sufficient. We need to act while we learn. So that's the big challenge, right? So this is Washington. This one you cannot see, so it's not across the US. You have this issue. Right. Again, if you go back into June 5th, this Environmental Day, the global message was beat plastic pollution. That's a singular cry for this year's theme. Why? Plastic is a fantastic material, right? And that's what the plastic people, plastic producers say. Now, if you see this wheel, this wheel indicates, they say they position plastic in the center of sustainable development. This is SD with plastic. You name it any place in the human society, plastics is used. So we don't, it's interesting. On one side, plastic is so pervasive, it's all over wherever we live, right? Yet, today the global cry is beat plastic pollution. But I would say it's not the problem of the material, it's the problem of us, right? We have been culprit in ensuring this. Because if I look at a little bit of history, now I just mentioned energy, now this is about materials, right? Elephants and forests, why I got these two? Plastic was the reason that people today we are having elephants. Elephants would not be with us if not for the plastic coming in. And if not for the plastic coming in at one place, perhaps in that country, forests too would not be there. It's a very interesting point. When Hyatt came up with the first nitrocellulose and then subsequently the bakelite, first plastics was created to save elephants because elephant ivory was the sole raw material to make billiard balls. And as the billiard ball game, billiards become popular across the US, they decided the number of African elephants or Asian elephants that need to be killed is going to be too much, and one tusk was giving about 4 balls, right? And no way billiards is going to be sustained if ivory was to be the raw material, because that is coming from elephant. So there was this national challenge. There's currently a plastic challenge in Sri Lanka, right? The national challenge to come up with an alternative material. And the alternative material was a complete invention of plastic, the very first plastic, synthetic plastics that came on. So it was to save elephants, and it did, right? Today we'll find bakelite and stuff being used before, but we started with that. And why forest? When the supermarkets came in 60s, when the mass production came and the people started consuming all that, and this one engineer, Stolin, identified the supermarkets were using paper bags and the paper was coming from forest. And he identified the single-use paper bag, nobody was really reusing them. And if this rate of consumption is going up, paper bags are being used, forest is going to be not there. Sustainable consumption, that's what we will be doing with life cycle analysis, all that you need to understand, right? Quantification, the material balances, how much of forest is necessary to do this much of production of paper. At the end of the day, they come from forest, right, trees. Today we have a term called sustainable forestry. So you take a photocopy bundle, you will see now some of them are coming from forest stewardship, right? Sustainable forestry. So Sri Lanka yet we do not have, we just protect, we do not have the sustainable forestry. As for paper industry, we don't have the paper industry. So this engineer came up with the first plastic bag, which is the patent there. The key thing was the handle in that, which is now a shopping bag and so on, was to save forest. So this wonderful material was developed and propagated to save two things, two very important things. Today we may have forgotten this. So today we have this, okay, beat plastic pollution. But the point is, yes, we have to beat plastic pollution. No question about it, because the situation is serious as well, right? Because these things were mass produced in starting like 1950, almost nothing, no million metric tons, right? Today we are talking about 400 to 450 million metric tons of plastics produced, and half of that is going to be single-use plastic. And single-use means you use and dispose. You don't do recycling. Today the global rate is about 9%, and Sri Lanka is much less. We are around 3%, even probably less, right? And what happens is, because plastic is there in the environment for 500 to 600 years, what was produced in 1950s, if unless somebody burns it, and I don't recommend burning that, right? It's bad, but it's there in the environment somewhere. And what we say is, it's there most of the time in the ocean. And today, if you do a calculation, if you look at the birth and the death and the consumption of fish and so on, the life cycle of fish, and also looking at the plastic is just getting deposited there. We're talking about 8 million metric tons of plastic coming into the oceans every year, right? So that 2045, you will see more plastics than fish in the ocean. Now that is a calculated equation. Now just imagine that, right? You go fishing, you get your plastic back. You don't get fishing. And now we have an even bigger problem that's not so worrying me, right? Now this is, we did this work in Sri Lanka, we did this research. And this is a serious case to me, I would say. And as a result, I will put in a toy standards committee as well. I can set aside. So when you just recycle, now we said, okay, recycling is for 9%, global average, Sri Lanka 3%. But even if you recycle, if you do it wrong, you have a bigger problem. What's that? Now these are toys that you see in Colombo, you can see in the Candy Colombo Road and all that. And okay, how does the plastics come raw material for these toys? And you know the child will pick the toy and put the first thing in the mouth, right? And so things like that, if it comes from electronic plastics, or in the plastics associated with electronic, there are fire retardant additives associated with those wires. So all of these wires will have fire retardants, PVD. They are not chemically connected, they are physically connected, right? Physically, and they get recycled into the toy. And you know, what we found was, when you do like a study, that it has a huge amount of bromine, which is an indicative of the fire retardant, because PVD is a fire retardant. And these toys have this, and a child will get in the mouth. And it's serious. These are internationally banned chemicals now in Stockholm Convention. So recycling is not necessarily the answer. You need to do the right way of doing that. And we are, for most of the time, even doing that in the wrong way because of some cheap plastics coming, cheap products and so on. And what is much more serious is that a study in US showed that babies, basically all the study cohort had 100% PBDE, PCB and those stuff in the blood of the child. 100% of those children, right? And the serious point is we are not talking about serious disease at this stage, we are talking about the lowering of IQ as the child grows. So each and every concentration goes up in the blood, there's a reduction in IQ. And usually you have a society that has a normal curve, right, the bell curve, and you will have certain challenge, but you will also have certain extremely good, and we fall in this marriage most of the time in the middle, right? But the point is, it shifts to the more challenge side. That means the society lacks maybe the necessary thinkers or the people who will have a little bit extra to take the society to the next level. So technically we will be having more politicians, right? Because that's why you don't need any qualifications. So this is a serious thing. This is not about big diseases, but just IQ coming down with this thing in the blood. And today we study body burden, right? And Sri Lankans, we have not had a chance to look at a body burden of Sri Lankan typically. It's an interesting thing. So what we found was very serious, right? And so we have this toy studies now, standards we put in and trying to get a limitation on Sri Lanka using these cheap toys coming to the country. Which is even more with the issue with plastic is this production of microplastics and the nanoplastics. A researcher in UK did the first identification of a dye that indicated the bottled mineral water, there is stuff coming into the water and we all are drinking microplastic. And today we have a calculation that says a typical credit card weight of microplastics we are taking per day or kind of thing. Of course there is a material balance, you will remove in some metal, but there may be certain things. But what is worse is, these microplastics become nanoplastics. And that can go anywhere in the body. There is no limit for nanomaterial. There is no way a body, no defense mechanism in the body to stop the movement of a nanomaterial. It can go to make all the places in the body. So the issue is still we do not know the critical level, right? Observable of effect level may not have been reached. What we know is, most of the time when we study, as you can see, microplastic particles detected in placenta of babies, and this happened during the COVID year, the very first study, and then today we are now finding it in blood and so on in the circulation. So researchers are really doing, but nanoplastic determination is still difficult, right? So this is serious. And what is interesting is now when we had this ship accident in Sri Lanka, or rather the Express Pearl, right, we had 11,000 metric tons of plastics just discharged onto our ocean. That is the world's worst maritime plastic accident, right? And not only that, we had fire and combustion as well. So when you know with chlorides and the plastics and so on, you had dioxins and furans that are forming as well. So we had a cocktail of chemicals that were coming out, and that's serious. In a sense, from a research, there's a rich research to be done because of the amount of discharge to the ocean, and it's all going to the fish and the sediment and the galmalu and all the stuff that are happening. So there is what we call biomagnification. Remember, in Mercury in Minamata, it took about 8 years for the first person to die. Right? Mercury discharge was happened from the factory. It took about 8 years plus for the first person to die in the Minamata Bay. Now today we know Minamata is an international convention against mercury, to remove mercury from use. So it has come to such a stage. The Japanese took it to that level in international movement, right? So it's quite interesting, but the point is, these are some of the things from Saratpur, right, where you can see various types. So not these simple particles, we have what about hydrolytic particles, polymers that are coming. And they are much more friable, they break into pieces, so it goes into nanoplastics much faster and can go into various pieces. And again on these things, today when the society has a fire, we fight that fire with chemicals, and today we call these chemicals as forever chemicals, and Sri Lanka used that, even though the international conventions are there today. To move ourselves away from these chemicals, we don't have to use the one that we had because those are the cheaper firefighting stuff. So there are about 15,000 PFAS on this system. They are called now, the term is forever chemicals, because they will remain in the system forever, way beyond our lifetimes and so on. Let's get actually later. And these are scenarios, right? So we need to move into this sustainable products, and sustainable products come from sustainable processes. So processes need to be transformed. So innovation has to come to the rescue. Interestingly, in Sri Lanka, you see quite a lot of stuff in plastics in them. We do now plastic roads, right? As you can see, plastic roads are happening. Then we have interesting trash to cash stuff, where the plastics and even composites now can go into this machine, and then you get your money. And then we have one of the world's two best plants. I would say two plants in the world, but this is one of the best. As flow sheet is a little better than the other existing one, where the PET bottles go to yarn, and then yarn goes over the world with the apparel. So, but sadly the point is they do not have sufficient quantities, because we throw away the bottles rather than helping that bottle to be collected. So the problem at point is not the plastic, but our behavior. We do not support the recycling process. Thereafter the decision process to be correct. So innovation still is to the rescue, right? So research, we have looked at research. We are again converting fruit waste into bioplastic. So that will be a major thing where we have to think. We are done with tomato and bananas, pineapple and so on, to what you call bacterial plastics, which is the greenest bioplastic at this stage, right? PA. So that's using the microbial processes. So we have a new bacterial process. But the point is, lab process doesn't going to solve the society problem. You need an industry to give what the society needs, right? That's what the traditional chemical engineering concepts of scaling up brings it. So we need to do that. So consciously, I just want to highlight this. So sometimes our organizations, we do this. Mine has a so this is where we have this organization. This is what I said, in learning and acting, we need to understand. So this was a case where we ourselves as a party, government has this, okay, coastal cleanup day, everything, and then you assemble committees and start doing. And okay, everybody across Sri Lanka gives a bit of a beach, and this was Lanka, so that our choice place, coming to closer to Moratuwa. So this was the before cleaning, and this was after cleaning, right? It looks different. But I just want to check after 1 week, I sent another person to see the beach, and sadly the beach is coming back to the normal in the sense of that. What is the function of doing these cleanups if it's for the day pictures and then you are adding more pollution anyway? The whole exercise is a big waste of time, energy and so on. And by drinking milk cartons and straws and so on, you'll be adding more pollution as well. So it's pretty useless. Right. So it's important that we do things that are right and we think about and take decisions. So this is what is important, right? So in a postgraduate learning, don't always take what somebody else tells you as well. Try to think and question and try to discuss it too, because it's not a case of bachelor's, we're talking about masters, right? And things need to be discussed and changed. So I'm just thinking, we need to make choices as individuals, and if we don't do things right, we are not going to get this process, we are not going to survive. So it's a seriously flawed thing that we are doing most of the time. So analyze, life cycle analysis is a seriously useful tool to get these decisions right. So we work on this impact. Everybody has to do that. Now that is sustainable process development, the very famous equation. The impact is related to population, affluence and technology, right? So population keep increasing, maybe sustainable at some point, but you're not going to say, look, stop population. Affluence, the way you live, yes we can, that's what we call sustainable consumption, right? But overall, people have been working on the technology. So overall, what I've been trying to say is how to change the processes to make less and less or even positive impact. That is the challenge we have. That is the value of the learning. That is the value of the research. That if we can slowly look at each and every process and change them to be sustainable, which help us to go into the living process of sustainable living. So that is, so we have new technologies that are coming in, like the case of use of locust effect in nanotechnology, right? What do? You have garments that need not be washed. So this astronaut was tested in the Japanese apparel for 3 months, was in the shape trip, based in the same underwear. Bit challenging in the mindset, but the point is, there's no need to wash concept. Just imagine situation of garments not needing to wash. You don't need washing machine, you don't need water, you don't need the detergent, you don't need the power. Of course, the biotechnology changed the earlier washing machine of hot water into enzymic use and saved energy. But today you are going another step further. You don't need to wash your garments. Major change. Of course, we have to have mindset change as well, because if somebody tells you, look, I'm wearing the same thing that I've been wearing for the last 3 months, it's a very difficult thing to digest. So technology may be perfect, but mindset may say, look, I mean, like, you find another scene to live, find an alternative place. Right? So these things need to be balanced. But these are happening. So for one thing in processes, remember, we can go back to nature. And when we look at sustainable processes, please think of nature as well. Learning from how the nature has evolved over millions of years, finding problems, solutions to problems, and so on. So so many examples today. The subject is called biomimicry, and very important in processes, because coupled with biotechnology you can do so much in this. So for example, this. So when the Japanese engineers had a problem with the high-speed rail, the physics was giving them sonic booms, and people who were when the high-speed train enters the tunnel, right, there was this big issue. And the neighbors and nobody was really liking that. But then they saw, okay, how this bird was doing the fishing. In a sense, high-speed entry into the water to catch the fish below, right? And there was no breakage, no waves were coming, and it was a way that was designed. The nature has designed the beak in such a way that knew that how the energy is dissipated, but and this was emulated in the new train design. So there are enough examples, right? When you take the heart pacemaker, the design, new designs came from observing the whale, basically the blue whale, right? The blue whale's ability to pump a lot of blood with that force, and the concepts were taken to simplify the heart pacemaker. Earlier the pacemaker, the very first one was just outside and was connected, right? So these are things, learning from nature and put that into a process development. So huge subject area, but very interesting. There's material development, understanding the very basic fundamentals of coatings, chemicals, excretions, whatever, and then even certain designs, the nature design. So this is a pure mechanical stuff in a sense, because it's a peak. This is coming up, and then that energy dissipation, it's all fluid mechanics, right? And different density, media interaction. So interesting. So this is another example. This is actually a chemical engineering professor who actually left the job after washing this beet fruit, right? He saw that beet fruit, when you wash it in the kitchen, the water is not getting wet, the fruit is not getting wet, it was rolling out. It's like the locus effect of salt. So he studied it and came up with this non-stained garments. So in 2005, this became the best nanotechnology invention, or rather the innovation, because it was marketed. So he left the teaching job and started licensing out the technology after research. So interesting. So no need to wash. After 50 washes, it doesn't get stained, right? So it's studying from that beet fruit. He identified what he called as small protruding whiskers in the beet fruit that prevents water wetting. Surface tension, contact angle, phobicity or the philicity. The concepts were put in, but the structure was the one. So you can change the structure of material and change the product, right? Behavior. So you have examples, I won't go into detail, but because people, like I said about Korea, 40 people changed Korea, and they were all scientists and engineers, supported, yes, but through R&D and development. So example of this agronomist in Israel, who came up with the very first drip irrigation system in the world, and transformed Israel to what it is today. It's a star country for agriculture, whereas the country is 62% desert. Sri Lanka goes to go and learn, try to go and learn. The very first thing sometimes some ministries do is go and study Israel agriculture, they come back and forget. But the point is, this is a transforming Israel happened from this drip irrigation identification, which was actually an observation in nature. Right? Observation of nature. Again, Singapore. They are specialists in membrane. They had to buy water from Malaysia. You know, you can't run a country by buying water from another country. Right? It's constitutionally guaranteed to get water. Right? When Singapore was formed from Malaysia. But they knew it's not going to be. So there is no such thing as sewage in Singapore. So when you land in Singapore, you will be drinking stuff that's coming out of the toilet. So try doing that in Sri Lanka, we will have issue. But the point is, that's what they do. But the point is, they use this technology to the highest level, right? So they are leaders in water purification. They are leaders in water harvesting, right? That's what I say that if Parakrama was to join in Sri Lanka now, he would migrate to Singapore. Because concept of not a drop of rainwater goes back to the ocean without being used is not practiced in Sri Lanka at all. We get floods on our way to the ocean, right? But Singapore harvests each and every rainwater drop in a bay. Either percolate it, groundwater recharge, or collect and use and so on. Starting from the airport, that's harvesting, right? So they know the importance. So that's why new water is reclaimed sewage in Singapore. And the children from day one do not get the word in the alphabet or rather the sewage. They use used water. So any used water can be taken back, which is what Professor Narayan was saying about the circular economy, cradle to cradle. Your sewage is going to be your drink tomorrow. Maybe not your sewage is going to be someone else's drink tomorrow. Right? So that's it. Again, for one thing, courier. Transform India, because some English said, sewer water in London is better than the milk in Bombay. He was not happy about hearing that about the milk in India. Today, Amul is the world's number one milk industry. They didn't bring cows from another country. It was what they had, and it was grass that they had. But the method, the process was made to ensure, and also the technology for getting. When everybody said you can't make dry milk powder out of buffalo milk, they did it. And this interesting process development exercise, how to demonstrate high-fat milk powder, simple process development, right? But as a result of that, number one industry in the world. So we need this paradigm shift, right? And process development. You can bring this new knowledge into the resources we have. What Sri Lanka is doing is we try to sell the resources we have. And sometimes some of our corporations sell the world's most best quality material and pay the monthly salary. Right? That is the situation we have in today. It is so unfortunate. Right? The one example I'm telling is about the third best quality in the world, not the first top, but yet third best quality in the world, we sell it and pay the salary. So it's not right. Right? So what has the resources need to come with the knowledge. Now that is what we need to have the processes. Just having the graphite doesn't get you anywhere. New knowledge gives you that this graphite is the world's only and one of the best, right? And graphite is a wonder material in 21st century. But what are we doing? We may sell the 1 kilogram to 200 rupees. So it's not good, right? But you need a serious investment for process. So that's important. So that's the theory. You need to bring knowledge based into it. So there is a lot of things we can work out scenarios where you don't have to have the factory, but you can have your knowledge. So you can run with patents, intellectual property, secure the intellectual property. So you develop the research well, you identify something new, patent it, and then production can happen in another country. Because Sri Lanka may not sometimes have space to do it. But if you capture the idea, that's important. So that's about designing Sri Lanka. You don't have to fabricate in Sri Lanka. Right? You look at an Apple iPhone, you will see design in California, produced in China. Who gets more money? California, not China. They will get for million sets sold, they will get some money, fine, yes. But the designer gets the more money, percentage of each sale. The royalty is much more. So you have different business models to drive. But for that, yet we need to generate that knowledge. That's why research is so important. Right? So we have enough opportunities with this. So even waste, so this is okay. Demonstrating $12 billion available from Sri Lanka using gem mining waste and mineral sand waste and appetite waste, washings, right? So these are things that are waiting for processes to come. We really do not have the process. We collect this, these are rare earths. So if you take a smartphone today, the smartphone has about 40 items from the periodic table. in one smartphone. 40 items, right? Now most of them rare earths are limited in supply, and these three places do have rare earths. But we fill the pit again with the rare earths, right? Because there is no process. So we take the gem out, fill the pit with more valuable material. Sometimes even much more than the gem. So it's interesting to think, what are we missing? Right? So it's about design, knowledge and innovation. Right? Again, Sri Lanka has one of the best clay deposits in the world. Nano clay deposit. We just don't use it. Right? And so there's so much of opportunity. So, but for that you need to bring this knowledge. So that's why these courses are important. But the point is, when you do these courses at the master's level, just don't use it just a note. Think what one can do with it. That's why I said learning cannot be done when you're learning. You need to act as well. There's so much of opportunity. Right? So it should be done that way. So likewise examples we have with this. Today we have something happening with graphene, for instance, for Sri Lanka. That's somewhat good because there has been an investment. So these batteries that are seen on top, now today Sri Lanka has reduced the graphene oxide batteries about 1,000 on the roads going through trials right now. Right? So something good for the moment. I mean, we are not target very seriously. And hopefully we will also have, the world is going to go hydrogen, and Sri Lanka stands to be benefited from this as well, because green hydrogen is you have your renewable energy and your water. So the two things that you technically need are the renewable energy and water, and you have green hydrogen economy. Of course, there's technology and processes inside that one has to work with. So hopefully, maybe we have these results in here, maybe in a couple of years' time at Moratuwa, by chain. So again, when you do industries, sustainability, sometimes think of working together. This is your semester 3 subject as well, right? Symbiosis. Now when you look at British sugar, they don't just look at sugar, manufacturing sugar. When we think of sugar, we only think of sugar, right? But sugar has so much potential, right? For instance, we don't see marmite houses in the country. We try to use molasses. We sometimes use molasses for dust suppression on the roads when the weather was kind of warm, right? But the yeast and the stuff is for $1 billion, kind of like $1 million industry, right? So marmite and so on comes from the autoclave yeast that comes from that. We don't use that yeast anymore, right? So we don't go through those processes where we actually bring the nutrition. We only use the product that creates a health hazard anyway, right? So we stop at that point, that yeast. So on the other hand, we can have the biofuels. So this was a case when the finance minister of Sri Lanka was driven by the work done here to the parliament on biofuels, right? But of course, he was to say that he came on Sri Lankan fuel and so on, but he forgot it after entering the parliament. So this was the case. So this was bioethanol, and where he was running through the parliament. But you can see that this connectivity, industry don't stand alone. Waste from one industry will be the raw material for another industry. And you plan your industries in that cluster, you can do quite enough. That is what is lacking for Moratuwa, right? We have a timber, but we don't have any associated industries for timber waste. But if you go to UK, you will find an example of timber cities. Right? The waste is used. So they don't want to use because they have limited resources. We have 2,000 mills, we have pollution at the end of the day. Right? So this is the point thing. So one can have this type of scenarios where industry-centered processes, but processes feeding another process, lot of products, no waste coming out really, which is industry symbiosis, which is exactly what in sustainable process. It's not just one process, so multiple processes working together, which is like nature. Nature, that is exactly what happened. But when we went and we started doing single things separately because we don't want, we optimized one, but now we have to optimize together. Industrial optimization, right? So with that, thank you, Aileen, I hope, and wish you all the best for hopefully dynamic masters, and that's what I think we need. And we need really serious research happening. So please, I hope, wishes that please do not stop stop at postgraduate degree. Don't look at a collection of a certificate, but try to engage in research and go into the masters and do that, even starting perhaps early in the project. Because that project really delivers, and cumulatively, that is where the real output will come from the master's course. Right? So it's important. So today, I mean, if you look at the famous Vidit Peki of Mudas Maratunga, the nation which does not create new things will not rise. He said this in about 1930s. Right? Even he was not here living when the independence came. But the second line also has now come true for Sri Lanka. Right? Like we're almost there. I think we're almost there before. So it's so sad to think, with so much of opportunities, we have not translated that. Right? So think about it, and while engaging in this master's. So I suppose, thank you for selecting the program, and it has real value. It's really relevant today for the future, but it's your engagement that will really put icing on the cake. It's an engagement. So thank you and all the best.
Thank you, sir, for your enlightening words. We have reached the end of the first half of this inaugural ceremony.
We invite all of you to enjoy the refreshment provided at the outside lobby area. Thank you.
test on. Check one, check.
The second half of this inaugural ceremony begins with a panel discussion on the theme of sustainable process industries and circular economy.
We invite Senior Professor Ajit T. Alvis, Dean, Faculty of Graduate Studies, University of Moratuwa.
Mr. Sanjeeva Cholakumara, Chief Executive Officer at Enaugural Lanka Private Limited.
Mr. Priyanjit Pereira, Chief Operating Officer at Phoenix Industries Ltd.
Mr. Indika Kumara, Head of Manufacturing at Unilever Sri Lanka Limited, to join as the panel members of the discussion.
We invite Professor P.G. Ratnasri, Professor, Department of Chemical and Process Engineering, University of Moratuwa, to conduct the panel discussion as the moderator of the session.
I kindly invite all our members to be seated. Very good morning, students. I welcome you all on behalf of the Department of Chemical and Process Engineering. This is our inauguration session. This is our next session. Actually, up to now, you have gained a very good understanding about the sustainability and the process engineering. And Professor Alvis gave it nicely how you broadly think implement sustainability to the processes, okay, as a society, and then we need to make changes in the process level. Let us discuss further this. Now, again, I want to introduce our panel members. Senior Professor Alvis, Dean, Faculty of Graduate Studies, and Mr. Sanjeeva Cholakumara, Chief Executive Officer at Enaugural Lanka Private Limited. Mr. Priyanjit Pereira, Chief Operating Officer at the Phoenix Industries Limited. Mr. Indika Kumara, Head of Manufacturing at Unilever Sri Lanka Private Limited. This is how I planned this session. I will have a two sessions with the panelists, and then finally I will give opportunity for you to raise the questions, okay? Then you can get more clarification regarding their views, so if you have new questions. Now, to begin the session, I will direct my first question to Professor Alvis. Sir, I think you told me everything what I wanted to ask from your presentation. But again, I will ask, when it comes to the process industry, how we call process industry sustainable? Can you elaborate the characteristic of the sustainable process industry? You can, I can.
Thank you. I indicated why we need industry.
Yes, why yes.
And we normally look at processing part of the industry. We can have different types of industries, but process industry per se. And traditionally, you can run a process where you can be what you call extractive. That's the difference when it comes to sustainability. We have been running industries in extractive nature. In the sense, we take things from the ground or things from whatever as resources, and we consume the resources and make we get things we want and then dispose the rest. So we have been extractive. So extractive nature need now be changed into what you call regenerative. So it's like cradle to grave, cradle to cradle. So the moment you go cradle to cradle, it's regenerative because I extract, I use, I process, I may take it into some form of waste, but that waste is again used as a resource and I come back. So we change our industry, the nature from an extractive nature to a regenerative nature. Nature is regenerative. Our processes have been very much extractive. After a while, if I run the industry the same way that I am doing now, I will find I will lose all my resources. Now I can't run this industry anymore. Now we have a situation, right? So now when we run sustainably the process industry, we will
not face that scenario. Energy will be kind of renewable, right? And the resources, we know what we process, we bring it back, go in circular fashion. I suppose you get it that way. Principal difference is extractive to regenerative. But that two big words, you need to get a little bit of philosophy behind.
Thank you, sir. If I add further, actually, we have to make changes to minimize the energy consumption in the process and less amount of water utilization when the process becomes sustainable.
We will always have the figures of footprint. I mean, we use this footprint calculation.
Yes.
You know what the burden that you are bringing on. So you can always work towards understanding footprint, resource footprint, energy footprint, all in formats, and then try to work towards the minimization of that as well. But when it happens that you are doing a regenerative in the sense it's renewable and so on, you identify, look, the beauty of it is you may need more stuff, but it's still more renewable because it's renewable. Because there's a difference between a renewable energy and other energies, you know, the energy densities are different. So you need to plan it out that way as well. I suppose quantification is always necessary. You know exactly what you are taking. So you know exactly what justice you are doing to the resources that you take. You have an answer to that question always.
Probably you will be learning that quantification techniques via our master's program. Right? Thank you, sir. I will come to later. And now I goes to Mr. Sanjeev Churukumar. Actually, it is my area. I know that you have been involved in this waste business for several years. Today, I want to ask you, especially students, when we get our master's program, it is a kind of circular economy and the sustainability. Actually, waste management is related with circular economy and the environmental sustainability. Now, when it comes to Sri Lankan industries, we have a big problem of hazardous waste management. I know that some of the industries, they have dead end. They have no solution for their hazardous waste. In that context, actually now locally, we have been able to find some strategies to solve this problem. For example, to tell you one thing about the hospital waste management in the Colombo area, private hospitals and government hospitals, we have one plant located in Kelowara village. They are doing incineration. Like that. No, that's the one. Hospital waste is the one type of waste, but we have sludges and all other electronic waste and different type of waste generated by the industries. Now, I know that to handle the hazardous waste, we are doing the co-processing and sometimes we do the resource recovery as well. Now tell me, Mr. Sanjeev, holistic approach. Can you briefly explain about holistic approach to the hazardous waste management in Sri Lanka?
Thank you, sir. Thank you for inviting me as well. Maybe I'll put, I think Professor Ajit has covered a lot many in terms of circular economy. Maybe since I have been there for the last 15 years, let me also try to add some of the inputs for your benefit, because you are going to have very good syllabus. I'm sure this type of people we need to run the organization. When it comes to waste management, of course, if I talk about waste management, we started in those days. I think I have gone to sometimes the multinational companies and talked to the backyard operator. They handle nitric acids. They don't know about the MSD as we call, nothing. But now the awareness amongst waste generators has also increased. If I talk about holistic view in Sri Lankan context, according as far as, don't quote me, as far as I know or we know, the hazardous generation in Sri Lanka is around 500,000 tons per annum. If I talk about my previous company, INSI, cement kiln co-processing can handle about maybe maximum 90,000. So maybe 25% of waste is being treated. When it comes to, so that is where you get the waste footprint in Sri Lanka. 25%, let's say, go to cement kiln co-processing. Hospital waste, of course, there is one company, they have very, very limited in terms of numbers. Balance goes to the waste to energy guys. They accept about 700 to 800 tons per day, but what I know is that most of the time, in Sri Lankan context, the non-hazardous, hazardous waste are being mixed up. And they have, that's your subject, and they have a lot of issues in terms of managing their processes, etc. So, and also, meantime, there is a sort of a national movement on having our own landfill. We have a lot of criticism over there. So, Sir spoke about the global recyclability or recycling or circularity gap is around 9% or 8 to 9%. Even in Sri Lankan 3%, but I believe is when it comes to industrial waste is more than, maybe less than that. So what I really need is, what I really know in the context of Sri Lanka is still a national need, unsolved needs. In like cement kiln co-processing cannot handle. There are a lot of difficulties in terms of handling, the hazardous waste. But when it comes to the waste profile in Sri Lanka, we have experience. It's very difficult to handle because we have numerous industries, SMEs, and different sort of industries, and waste profiles are extremely difficult to handle. When it comes to other cases, like my previous company, cement kilns, like some of the negative impact that we are getting to cement kiln, the process, the sustainability, environmental aspect, the occupational health aspect, we cannot handle it. So that in terms of holistically speaking, Sri Lanka needs more solutions, sustainable, and there are solutions in the world, but we need to bring it. But mostly the barrier is sometimes the technology, sometimes the economically it's not viable. And also, Sri Lankan companies cannot afford this sort of high-level, technology, the cost of service. That is another reason. Hope I answered the question.
Yeah, thank you very much. I think you answered. Just to add you on the top of that, what I actually in 2017 I visited Finland, waste park, run by the Portum company. You will see that they have found the total solution, zero waste on the same spot. You have incineration, you have anaerobic digestion, you have recycling, everything is there actually. Ultimately, they have a very tiny landfill, what you cannot actually treat. You see, you cannot treat all the pollutants, you cannot recover. Ultimately, something you must have to go to landfill, right? So that type of total solution is appropriate for the Sri Lanka, but very technologically and the economically bit higher. You have to spend a lot of money, and the technology is also needed. So as you told, still we don't have that concept in Sri Lanka. There is a waste park.
Yes, waste park concept is not happening, but I have seen a lot of industrial symbiosis approaches. Like as a good example, Moratuwa is emitting fly ash. We have a cement plant next to that, and we have a developer product to take this fly ash, blend it into a new sort of a cement product. So which is again an hazardous waste, but we have a solution. And again, sometimes like extrusion industries, we are getting sludges where we have some inorganic part like aluminium, ferrous, etc. So as other industry, like as a cement industry, we get benefit as well. It's really a industrial symbiosis. To address your point, of course, total service solution, we call it in waste management, through an industrial sort of a part. It's not happening in Sri Lanka to a great extent.
Thank you, Mr. Sanjeev. I will come later. Now I will go to Mr. Priyanjit. You have been in the polymer industry so many years now. Let me ask this thing. As you know, in the polymer industry, actually we have this injection molding, blow molding, extrusion. Those are very high energy consuming process or units. Can you tell me where are the places we can apply sustainable concept in the polymer industry?
Actually, now this polymer, I will take plastic. First, the polymer, for example, as Professor Ajit is trying to mention in his presentation, we are approaching in this sustainable aspect in 5 areas. Like, first of all, you try to reduce plastic consumption. For example, we are working with many customers how to reduce the plastic content of the product. We are doing a lot of research and development, and we have a very good R&D team, and we are doing a lot of researches and try to reduce the weight, for example, like that, and try to reduce unnecessary components, especially for the specific items, and we are doing design of the product in a specific manner that where we can have the sustainable aspect of the product, like that we are doing. The second thing is then we can do reuse the product, like that. So reuse the product means, for example, we are producing our ice cream container to elephant house and cargoes. So we specifically produce that product after you consume. You can use it to another aspect, like store other items like that, and as a lunch boxes sometimes, and you can use it like that. Phoenix, definitely we are in agreement with our management. We have a very solid team. We have already decided that not to invest any single mold, anything to single-use plastics. Because single-use plastic is, as Professor Aditya is rightly mentioned, because plastic today we cannot live without plastic. For example, even the saline bottle is plastic, stethoscope is plastic, MRI scanner. Even we cannot have this 70, with the plastic introduction to the vehicles, we have 70%, 60% energy efficiency with that. So we can have any flight of aeroplane without plastic. So we need that plastic interference to our day-to-day life. But the thing is, as Professor Aditya has rightly mentioned, there is no any mechanism and proper ideology how to use this or handle this post-consumer plastic item. That's the difficulty there. So then Phoenix and our whole team is now these days we are using the third R aspect called recycling. We are doing our mastering and our all R&D activities in that area, where the recycling process is the most key area that we have to work on. And for example, in 2100, the economists and everybody, socialists, they believe that the primary product of plastic is, crude oil, that's going to be depleted. So we won't be having any maybe virgin plastic by 2100. But we have already used plastic. That's the problem. So even our mobile phone is plastic. The laptop, everything is plastic. So then what will be happening there? So that plastic, the recycling is the most. There are two concepts of recycling: is mechanical recycling and chemical recycling. So those areas we have to master. So in that scenario, Phoenix, we went in last year Germany to attend K-Fair, and we saw that all the slogans, all the posters, everything is in the circular economy now. Because Germany, I will tell you, when I attended to K-Fair last time in 2016, sir, the plastic recovery, recycling ratio in countries around 65%. Now last year when I went there, it is 85%. They are promoting plastic. Honestly, Germany is promoting plastic. They believe that, and that's all the civilians, the attitude is towards the recovery. Now in Sri Lanka, what is happening? Our day-to-day, our civilians, they segregate plastic. When you dump the plastic to our municipal council lorry, all get jammed again. So no point of we are doing segregation anything. But Germany is not like that. Everything is system. Everything is there, place. So recycling is the third aspect that Phoenix is working on. And then another area we are working is rotten. Rotten means R, it means compostable. Compostability. Honestly, for the single-use plastic products, such as, for example, lunch sheets, we have already introduced compostable materials, which is produced by using cornstarch 60%, and other materials are PLA and PBA, bio-based materials. and those are 100% compostable. We are not believing in biodegradable honestly, because biodegradable create microplastics. It's just additive and it's just break polymer chains and create microplastics. So we are not into that. But definitely we are in the compostable way. This 100% compostable after 6 months. Those kind of material we are trying to introduce to the single-use area, but not petroleum-based plastic for those areas. Another thing is reduce. As a plastic company, I am not telling not to actually to reject plastic. We have to accept plastic, but what time now we are working with lot of government associations, CEA, Ministry of Environment, and we are actually promoting, and already know that Sri Lanka, there's a policy called National Action Plan of Plastic Waste Management, and it is there's a clear guideline and we are actually aligned with that, and we have even our managing director Anam Moma, everybody in that committee. We are 100% drive this Phoenix goals, because being the largest plastic manufacturer in Sri Lanka, we have EPR, Extended Producer Responsibility, to reduce these issues being introduced in the plastic item to society. So these 5 R's actually we are working in a sustainable manner, and that's how we are working.
Yes, thank you very much for your more elaborative answer. Actually, I already asked about the EPR, and then you finally told that. So you are responsible. Thank you. I will come in the next session. Mr. Inaugural, actually he is our product from University of Moratuwa. Now, students, you know that normally in the morning we wake up with the Unilever and go to sleep with the Unilever, right? So that is the brand name in Sri Lanka. Mr. Indika is actually chief how we called head of manufacturing in Unilever. So let me ask this thing. Even our chemical engineering students are actually working there. So let me ask, when you come to your manufacturing and supply chain, can you tell us where this sustainability aspects can be applied in the entire manufacturing? For example, you have actually this past, the consumer goods items like that detergent, soaps, and there are so many items they are producing to the market, and you are a global company actually doing the global business here in Sri Lanka. Can you tell us where the sustainability can be applied in your total manufacturing and supply chain?
Yeah. First of all, thank you for me to invite to represent this event, and for the Unilever to give some insight with respect to sustainability, right? So, answering to the question, so let me give brief introduction of the organization and how you work with respect to sustainability, right? So Unilever is the second largest global FMCG manufacturer. So we are the second largest. So basically we operate in 180 countries in the world. So that means all over the country, right? So sustainability is, let me explain it this way. In 2010, Unilever has taken initiative to launch a concept called sustainable living plan. So it was our mantra to operate the sustainable, because we identified that the trend is coming towards the sustainability, and since we are one of the biggest FMCG in the world, we have an obligation to protect the environment, right? If we are not leading it, nobody will not lead, because in context, people are looking at the MNCs, how the MNCs are operated in the countries and how the MNCs are working in the global context. So understanding the importance of leading that, so we are one of the first company who introduced a global agenda called sustainable living plan, right? So there we introduced a concept called double the business while halving the environmental footprint. So we double the business for 5 years, and we are reducing the environmental footprint in each and every area. So that means emission and everywhere how to reduce the environmental footprint by halving the environmental footprint. So we ran that organization, that agenda for 10 years. After that, in 2015, Unilever signed a UN treaty, sustainable agenda. And after that, 2021 also we introduced a compass organization structure. We understood that the sustainability is not purely a supply chain part. Which initially it was a supply chain part, but to be a more responsible organization, that we understood that it has to be part of the brand as well. You cannot, supply chain is because supply chain, the purpose of the objective of the supply chain to produce what the consumers are requesting. Right? We need to be competitive in the market, yeah. So otherwise people not buy. So for example, we can sell product containers with very high costly, but people will not buy. So the thing is, it has to be embedded in the fully integrated corporate strategy. So at that point, you will even take a compass, that strategy called compass. So basically, we believe the organization with purpose lasts, right? Where your purpose is to, then we change our purpose for the organization and the vision we change. So the sustainable living for common place. So they change their vision into the sustainable angle. So with that, the organization, each and every BU, we operate in 5 BUs. BUs mean business unit, right? So the home care, personal care, ice cream, and likewise, we have 5 BUs operating. So all the BUs, they have given the top 5 into the brand has to be aligned with the sustainable. Whatever the product that you are going for the market, and the brand strategy, brand teams also, they need to be aligned with the sustainability agenda. So coming to the supply chain. So supply chain has a very clear objective, and they have given a very clear targets of to reduce how to operate the supply chain sustainably. It does not limit to make. In the supply chain, there are planning, procurement, logistics, and make, right? So it's not limited to make. So make means how you operate in your factories. In the factories, we have very clear cut target which is coming from the global level. Global, they have signed up. For example, 2030, they have to, the operation has to be carbon neutral. So understanding that organization has a regional wise, country level, they have given a target to how to operate and how to reach that destination. So then when the organization is strategically driven, those things are driven, then you will get the funds. The country level or the plant engineers cannot drive all these stuff, or the country heads. The organization purpose and the organization value and the organization strategy should be aligned with that. So you will have a separate expenditure for every year. We are investing continuously on the sustainability. When it comes to energy, we do solar, and not only solar, some factories in India we have wind plants. So we are installing wind plants. We have 2 factories, we have 2 wind plants. Right? So likewise, we are continuing. Some projects are not IRR projects. That means some projects are not saving projects. Everywhere you cannot get saving. Most of the business organizations, they invest the sustainability if they feel that's a saving project. It is not the approach for us. Sustainability is a common agenda where everybody has to be aligned. And so we identify in Sri Lankan context, still solar is not the IRR based investment. But companies are investing on basically only the sustainability. So there are, when it comes to raw material front, right? So raw material also we have a separate concept, RSP, we call it responsible sourcing partners. We look at how our manufacturer, because raw material we buy palm oil, we buy whatever the thing, then we get most of the manufacturers which happen in the third parties. So usually we have only 280 on site in the world, but we have more than 1,000 third-party factories operating in the who procure goods and stuff to Unilever. We need to look at them whether how do they manufacture, because when you understand value chain, the supply chain, it starts from the raw material. We need to look how the raw materials are produced by these manufacturers. It's not our processes. So it's not limited to our process. We have to look at how the raw material are produced. For example, we need to look at how Phoenix is making their bottles. So we do partnership with them, and we were continuously working with them how you improve efficiencies. Right? So that's come for the raw material. When it comes to manufacturing I told, when it comes to packaging, there's a huge responsibility on us because we are the market lead of the almost all the categories that we leading in Sri Lanka. It may be soap, it may be toothpaste, whatever. So we are the market lead in almost all the categories. We should showcase our commitment. We should showcase our commitment to the business and to the entire community we are working towards. So some changes what we have taken, it's not, people will not feel. For example, if you take the sunscreen bottle, we have reduced the plastic. We have considered reduce the plastic content of the bottle, but there's a risk of cooperation because you will feel holes may be there, bottle holes may be there, it may be damaging the trade, it may be damaging people and they will get more market returns because of the damaging the retail market. And the other thing, when we are going to the laminates, the government has banning. So now, before that, we started working how we go for the lamination. So sachets. Sachet was the biggest culprit for the environmental pollution. So now, still we have laminate. Surface, we have 20 gram, 30 gram, 200 gram, whatever. But the cost of packaging, because of that, we cannot change for the container type. Because then people will not buy, right? So then we are working on how to convert these sachets into a recyclable platform. So that somebody can argue why you can't immediately do it, but the technology for that and investment for that and the machinability of that is very much serious difficult for us. I know when I was with I am a plant manager in the personal product plant, we tried to enormously work on the converting this the normal sachet into the laminate which can be compostable or whatever. So the recyclable are also very challenging because machinability, people, capability. So when you are running for this material, normal virgin plastic for the laminate, we can run the line without any issue. But we converting into recyclable, waste generation of the factories gone from 0.5 to 2% level. The 2% material waste mean that we have to charge from the consumer. So then either you reduce to GM, business operating model will be business operation model, business model will be challenged. So that's a challenge that the industry is having to try, because at the end of the day, this has to be business as well. Whatever thing, it has to be give return to the business and it should give some return to the stakeholders, especially people who are invested in the business. So we should strike a balance. So we are managers, right? So there are owners of the business, so who need the equity. At the end of the year, we need to pay some for them. So there should be we need to strike a balance on that. So we are investing and we are improving the capabilities of the factories. So but still there are huge challenges where the real talent is highly required for the industries. So that is from the packaging. And the other thing, we are doing partnership with the people, some organization. I think easy we have with the partnership. We are trying to collect the plastic. We are collecting. So plastic from the market and the collection is the problem. So we join with Coca-Cola, we join with EC. We having a collection center. So the EC's collection do the collection plastic from the market and they do all the separation. And as the market leader, so only few companies are coming forward to that because the pressure group in the consumers and the pressure group is not much visible in the market. People buy whatever thing, they don't concern about whether how the product is developed and what are the raw material, whatever thing is sustainable, whatever people buy based on the point of price. But the context of country Sri Lanka that we have right now is not good time for the sustainability because people buy if you pay very low price. The only concern is for the right now is the price. But if you work for the sustainability, you need investment. So where we need to pay depreciation, then we do cost of manufacturing increases. So there's a huge challenge, but the organizations are working on it, and we are having a partnership with INSEE and the Phoenix. So we are trying to working on. So there are a huge opportunity, and we need new talents and the new knowledge for the industry. I think this course will be a real platform for that. So as market leaders, we need to drive the sustainability. When we drive sustainability, local companies definitely they have to engage or embark on the journey in the sustainability. So we are continually working on it. Thank you.
Thank you, Mr. Very extensive and elaborative explanations. I think sustainability is global, it's not the local, right? So you are entitled to follow that global sustainable guidelines. even when you come to local nuclear plant. Now again I go back to, I want to start the second session to Professor Ajit. Ajit sir, you explain what you want to ask, but I think students, industrial symbiosis is a very important thing when you come to implementation of a circular economy, right? When one industry produces the waste, that will become a raw material for another industry. I think sir supervising 2 PhD students in this area actually now they are completing their PhDs, right? I'm very happy about that. So can you explain in the future Sri Lankan industrial setup how we should think about this industrial symbiosis?
I mentioned about the sugar industry, but there are so many examples that we can think of. Initially, probably in the planning, I think what you said now, Unilever plans with Phoenix on the front end, and then plans with INSEE on the back end, right? But they all together. Now, success of one industry depends on the success of the industry. They also successful. When you grow, they grow as well, right? So I suppose that is what. Now, if you just think planning three parties in isolation, that won't be a good industrial partnership. Now, this is what exactly we are talking about. Only thing is here, in symbiosis, seriously we look at bringing industries closer. Let's say we have a timber industry at Moratuwa, we have 2,000 sawmills, but we have sawdust. What are we doing with the sawdust here? At the moment, the sawdust is being, even we pay money and dump it onto the warehouse sugar, and either you burn it, and sometimes, most of the time, to get the environmental protection license from CA, you put up a very crude incinerator. I won't call it an incinerator, you just burn it by the side. So if you have the burning unit, you get the EPL to run the sawmill, right, or the timber mill. Now that is not proper because one third of a tree is actually lost as sawdust because of the poor technology. So that's the story of Moratuwa, right? Now here you can plan, okay, what to do with the sawdust, what can we do, MDF. There are other things, and then we can you think of sawdust into compost, and then compost can go to mushroom farming. Mushroom farming can be a really seriously economically optional industry, right? So the timber mill, look at the mushroom grower in harmony. I mean, like you have a timber mill, by the side you try to even have a mushroom grower. Maybe sometimes there can be different distillation units that can come in to extract the wood alcohol. Things can go in, you can plan out different industrial plants. So essentially you are not having any waste, and maybe the energy can come from Moratuwa. We now get our energy from the outside, CP, right? Moratuwa industrial estate can get energy out of gasifying or doing with the biomass that is generated from the sawmill waste. Now you can have an energy related recovery operation as well. So without doing that, we waste the sawdust, which has calorific value. We buy energy from another place. So this is symbiosis, right? The nature symbiosis is sometimes you see the crocodile open the mouth, the dentist is a bird. The croc keeps the mouth open, and then the bird lands on the mouth and then clean the teeth, basically the scavenge food. Now you can have some quick meal by closing your jaw and get the bird in as well, but you don't do that. You don't kill that bird. You go and kill something else, but the bird is the dentist's job. So the nature has so many examples of working together because each one helps, right? Now that concept is put in the industry. So industry should understand the waste that are coming, putting together. Now that is why we normally say industrial estates to start with. Sri Lanka has the world, this region in the Indian side. The first industrial estate in this side of the Asia happened in Sri Lanka, Ekala Jaya and St. Catherine's Ratmalana, right? But where are we? Right? Ekala Jaya. That when you put industrial estate, you have to think, look, if you bring one industry, the other industry should also be working with that industry. You can have completely different types of industries that are coming in that really, okay, you are in the estate for the sake of being in and having a land, but there is no relationship between the neighbors and so on. So that is what see when you say Ratmalana, now when you see some of the industries, there are no relationship with the neighbor. You go into an industry, sometimes you ask who the neighbor is. You have no idea what the neighbor is doing. I mean, you know what the factory is producing, but there is no relationship. Now in real symbiosis, being close together, you try to see like, look, what I am producing, there's something that I can work with the next. I remember when the sulfuric acid plant or Ranala was taken out, there was a tribal movement to put that Ranala sulfuric plant into the Lindell estate to be next door to the Almex. The idea that was needed, acid was needed for pickling operations, right? So an acid plant next to the aluminium operator and so on, that is together, you have captive use. So that's the kind of thing you should do. So if in the industrial planner, think only your industry, your product, your cash flow, you forget everything else and you are just trying to sell and live, you will not have a good success story. There is always success when maybe your part of the waste becomes an investment to another, and that person may be more successful for having that investment, right? Whereas you may not get invest for your waste upgrading. Waste as a result, that's somebody else's task. You bring the industries together, you can have real good value coming out. That's what we should try. Now, Sri Lanka did the sugar industry, paper industry in separation, because most of the time we got our industries as gift from another country. So you get the gift, train the people there. You don't look at industrial planning. You plan to run that industry. So that's one of the reasons that our industries actually went down in efficiency. So if I take sugar industry and the paper industry, availability and the Senegal and so on, it would have been nicer to plan the waste, the bagasse from the sugar industry to be the paper raw material at the paper factory and get the liquor coming back into the sugar to the energy generation. Now that is, if you have planned two industries together, we probably would have a paper industry today. Now we plan a brand new recovery method for the caustic recovery for the availability and be paid even before the proof of concept was shown. So the reasons are we planned just the paper, or we had this gift and we just ran it. So industries need to be working together like in nature. That's the essence of it. So raw material in, energy in, product out, waste out. Your waste out should go into something else. And so that is connectivity. The block diagram of multiple industries working together.
Thank you very much. Thank you. Then I go to Mr. Priyanjit again. Actually, we know that any industrial operation involves the environmental impacts. Environmental sustainability, for example. When you come to polymer industry, when you do these operations, can you tell them briefly how you minimize these environmental impacts?
Exactly, when we do basically the recycling operation, most of the material recovery facilities, they are doing a normal regulated mechanical grinding process where your dust, noise and everything is too harmful to the environment. And again, sometimes microplastic is created. There is really now even our Ministry of Environment and CEA had already put their most attention to control that. Even I think by this meeting we have a big conference. We are also participating in that, how to reduce this microplastic effect to the environment. So these kind of issues are there with this recovery. We are doing this recovery and recycling. We had seen this issue, I think 1 year back, 2 years back, and now we are deciding already to form a state-of-the-art recycling facility. We have already bought 15-acre land in Padalagama, Mahapanduva, very close to our clinics. Now we are going to do a state-of-the-art recycling plant with the good technology. So purposely we have already visited German Cape Fair to get that technology. And we have to work in few areas. For example, how to collect this plastic. Then second thing is how to do the segregation, separation. You know, that's where most of the technology is needed to the civilians as well as students and even the children in the schools. You know that plastic is very essential to us, but our people actually they don't know how to separate plastic, identify plastic even. For example, number 1 recycling symbol is to PET, and then number 2 is to HDPE, number 3 is to PVC, number 4 is to LLDP, number 5 is to PP, and number 6 is to polystyrene, number 7 is to other, and number 9 is to ABE. ABE is acrylonitrile butyl styrene. They are vehicle parts. Most of the electrical parts are being manufactured by using these materials. But now, without having this knowledge, for example, nobody knows how to separate this plastic. But this plastic we cannot mix. Then quality of recycling is deteriorated. So nobody knows about this. So and our Phoenix now we are in the process of teaching school children. Right. And we are highly, now we have Lanka Center College, and also we are working with EcoSpindle. They have plastic mama concept, and we are also supporting with them, and we are going here and there, we are teaching people. And we are highly recommending by Ministry of Education and Ministry of Environment to add this subject into syllabus of school children. And because plastic is very important, and we can earn money. We can earn money because now Phoenix, our effort is to convert 2,000 metric tons per month, not to internal use, but also to sell. Because reduce can be happened by reduce the plastic content, and also we can reduce the virgin content of the plastic. So that's also it's a reducing aspect. So we are working on that, and most probably this will be happen. And this another thing is noise. How to reduce the noise is there are a lot of granulators that now it's soundproof granulators. Soundproof granulators, and also this. To eliminate the dust effect, there are a lot of equipment now already we have seen. Now China is also doing very good. For example, Polyretech is one of the best companies having very good German quality technology in China. So now we are working with them honestly. And they have wet grinding, which is called wet shredding. And then after that, these flakes are subjected to abrasion washing. It means chemical friction washing and chemical washing. And after that it's drying, and those flakes, it's a fully automated process. And then after that there's another process. Even separation is also can be done by using ultrasonic sound technology. That's also there. And then these dried flakes then can be pelletized. So those are now fully automated. Now we are working on that as a solution for this issue.
Thank you very much, Priya. As I understood, your new German plant will come up with the online monitoring system, no? With all the emissions, and that life will be much easier, no? So thank you very much. Now I come very quickly to Mr. Sanjeev. Just a very simple question. When it comes to handling hazardous waste, collection, transportation, processing also is very difficult. Can you tell me what are the challenges in particular hazardous waste handling, this transportation and processing?
Thank you. I think handling industrial waste is extremely difficult task. I think you've been a chemical engineer, chemist, etc. You know what exactly the challenges. Our main challenges when it comes to industrial waste is to handling these heterogeneous materials. Like you go to today Unilever and to someone else tomorrow, and you get same sludge and completely different chemical formula. So we have, when it comes to cement kiln co-processing, it's again we are putting waste into cement kiln. Two processes are happening simultaneously, clinker manufacturing as well as the waste disposal. So we are extremely careful. We cannot put anything and everything to cement kiln here or Sri Lanka or any other part of the world. So we are extremely careful so that one of the bigger challenges what we have is to handle this chemistry. Because we handle at least 5,000, 10,000 types of waste here in Sri Lanka. We've been one and only the, that level, the hazardous waste company. So what we have done is to mitigate that is we have a 5-stage quality control. Like many people are blaming the cement company or taking time, etc., etc. So there is a purpose to do so, because we need to manage the chemistry, and also since it goes to another process. Like my quality manager and the process guy is coming and taking, and our environmental manager is coming, okay, your NOx is going to be high, your heavy metal content is going to be so and so forth. That's the one challenge in holistically speaking. The second challenge I would like to say, and the composition are changing drastically. Today we sign agreement for some waste and tomorrow is giving another waste. So how we can check? So there is an ample amount of effort in quality assurance and controlling. So we are doing it at various stages and we reject sometimes the waste. And we cannot go and tell our clients, I cannot tell Indicat, okay, Indicat, I want this much of chlorine, you make your product accordingly. Cannot. He has another way of production, and sometimes the product itself is needed. Like one of the joke we are saying is like we had an aluminium extrusion industries and they are using sulfuric. And sulfur is going to be killer for us. Sulfur incrustation in cement kiln is a big problem. It's huge cost. So I just asked jokingly, can you use nitric? They said, they laugh. You can't use nitric instead of sulfuric. And also we have another good example as well. We realized that if I take time is okay, right? Yeah. We realized that one of the largest the fabric mill, and we found that heavy content of chromium. And we immediately went into that they didn't realize that chromium input. And big thanks to us, then they realized that one of the technical grade material which we are using in water purification from China or whatever, and it has chromium. That's where but Indica said, you reject in your product, in your procuring process, if you have a good visibility, you can reject it. So the third challenge that we have is the environmental concern, because so we have continuous emission monitoring systems, we have other safety measurement, etc. And also cement is industry where you emit CO2, so we have to mitigate that as well. So another challenge is an occupational health and safety, and I think it's your subject as well. Like it's very difficult. Like you need to see all the acute chronic impact in handling waste is a serious concern. And also another biggest problem for us is the waste compatibility. Like if you mix acid and base, your exothermic reaction will burn your facilities like that. And another challenge is to bring all state of the art. We've been a multinational, my previous company, multinational, to bring all these state of the art into place, and how much I'm going to charge to my client. So that's another bigger challenge. So we can bring it, all the required facilities, but can that be affordable for companies? So those are in brief some challenges.
Yeah, thank you very much. I know that composition area is actually the 1 hour maybe, no?
Yes.
But you have very sophisticated characterization techniques, no? Yes. To have heavy metal and all these things. Okay, thank you very much. It's a very actually interesting topic. Mr. Indika, my final question, I think you have very extensively elaborated what are the initiatives taken by the Unilever to make the process sustainable. Very briefly tell me, among them, very practically prioritize what are the very significant among them, the initiatives you taken very recently?
Yeah, basically, if you take in a big holistic way, in a brief way. So basically, one of the key priority for any company or what we are driving right now is the manufacturing excellence. Right? Manufacturing excellence is the key priority for sustainability. So we are driving hardly that. That means we have separate Unilever manufacturing system across world-class manufacturing. So where we look at all aspects. So the thing is, so if I take few example from that, you cannot improve without measuring. First thing you measure, right? Whatever energy you have to measure. Whatever the plastic or everything you have to measure. All the input you have to measure. So now we are using, we have a separate concept called smart factory. So where we have in the Sri Lanka, we are globally we have identified 30 factories. Sri Lanka we have taken Corona as our lighthouse factory, where we measure everything. So energy measuring is the one of the key, where we have putting huge money to for the automated measurement system, where the energy, water, electricity, and everything is in the dashboard, where you can measure and you can understand the tendencies, and you can sync with the plant managers and plant engineers for app and phones. So where we can measure and all the efficiency, where you can improve the efficiency. So that is the biggest novel thing that we are driving, especially at the AI part, artificial intelligence. So we are and the data analysis. So we are now putting those technologies into the operations where we can get more and more benefit, because most of the time we get the report at the end of the month. We know what is the electricity. That will not work. For the sustainability, you have to measure what is happening in the process. So they are putting a lot of data analytics and new technologies, new applications to analyze the process and get the on-time visibility of the process. That's the one thing. Other thing is what we are doing right now is the rainwater harvesting. So I will take one or two. So rainwater harvesting, we are collecting 25% of our collection from the rainwater harvesting, and we are trying to put them into the product. So basically we are getting raw water and we treat it and put into the product where the manufacture shampoo and conditioners and everything. But we are now trying to put them into the product and it, because there are some concern for that, but we are clearly, and it will be that way. Another thing is the basically I will take another one from the packaging. So we are drastically working on adding recycled plastic into the product and reducing the virgin plastic consumption. So we have done a few works and they are working on it, where around 30-40% of at least the virgin plastic reduction from the by adding recycled plastic. There are many initiatives we are working on it. So, and we are working with organizations like Eagles, Good Cities, and put some plastic collector with what you are seeing in the presentation. So we are continuously investing on those things. So, last and not least, but is the capability building of the people and the management. So to get this benefit, you are running your organization with the management, right? If your managers don't believe this, you cannot make it. Right? So basically, if you go to a factory, you can understand the level of the management. How do they run the factory and what is their depth of running, and how do they believe the concepts. Right? So for that, we are improving immediately all the capabilities of our managers who work in Inaugural, especially technical staff and the senior management, top level management. It's a crash course program. We are improving, we are putting them. These are the concepts, these are the global trends. So we are having a global network with it for in the other countries. So these are the trends. So these are the things that we are doing right now. I think it will give a good benefit for the not only Unilever, for the entire society, where the other companies also will come after us. Right, thank you.
Thank you very much, Mr. Sindhika. I think we have come to the conclusion. Let me thank all the panelists. Actually, very fruitful discussion we had. The students, I think you will be able to learn the sustainability and the process engineering. As Professor Narayana very clearly mentioned, the modules we have formulated. Start with the process synthesis, that the selection of the root cause reaction, until you go to plant operation and management, right? All these intermediate steps, we can map our course module in your program, right? So you will be able to learn all those things in the theoretical, practical, and very closely collaborative with the industry, right? We have more industries than only few people actually today we have invited. We have very nice collaboration with the industry. Once again, thank you very much for all the panelists. So I conclude our panel discussion.
Some questions from
sorry, I forgot it because I am looking at the time. Right? If you have, thank you very much, Professor. If you have any burning questions, you can raise. You may also. I apologize for that. I was thinking about the time, right? Any questions? I want to ask sound. Please talk. Right? This is your course, any question, any clarification? Yes. Please give me the mic. Yes. Very good.
I have a question regarding recycling. So, recent articles published by Berlin Forum, they are saying recycling 142 lines is enough with the properties of the actual properties of the product. So, at the moment, as a sustainable process of building, what do you think that what actions you are looking at the moment to gain the basic virgin product properties when recycling to plants in the product?
So you mean after recycling you will change the...
So one item can recycle 2 or 3 times as after the properties of the
Yes.
So at the moment, so what kind of...
Maybe realistic. Yes.
That's a very good question. So, and also we are also have already put our attention on that, because recycling, when we are doing recycling, not only the number of recycling steps, when the quality of the collected items, for example, it is exposed to the environment so much of time, for example 3 to 5 years direct from sunlight, then already that plastic is not good, it's already deteriorated. That's the major issue that we had. So now we are working with a few companies. They have a lot of ingredients to enhance the recycling properties, and they are modifiers, impact modifiers, enhancers. There are a lot of ingredients we can add there to enhance that properties, but not into 100% virgin extract, honestly I tell you. But what we are doing is, now we, for example, where the strength and other properties are not paramount important, we can identify a lot of products. For example, beverage, small FMG products, and other products, we can add that materials not into big extent, 100% not like that, but into small percentages, up to 40% like that. And sometimes we mix with the virgin. And there are some items we can 100% add this recycled material where the strength and other parameters are not so important. So we are use 100% add that material to those items, and we use maximum out of recycle like that. So into these 2 areas we are working on that. But mechanically when we are recycling, the research found is not deteriorating in so much extent. With just, the polymer chains are having only Van der Waals process. When you melt it, it is slip over 1 hour, and especially polyethylene, those are not deteriorating into great extent. The amount of number of your recycling cycles, but the most damage is happen when the plastic is exposed to the environment. When you also the UV degradation is happened, the polymer chain, the polymer length of the chains is breaking into great extent. Where the strength is having big amount of frictions. In that area, we are working on that. We are a lot of enhancers, modifiers, we are adding like that, and we are improving the recycling.
Yeah, adding to that, basically, we have an example on this. Basically, when the recycled plastic or the things are developed by the suppliers, so the manufacturers, the product manufacturer like us, we have a separate responsibility to changing our quality parameters. The thing is, he can manufacture, then it comes to the factories, factory quality indicates this is not acceptable, strength and whatever. So there's a partnership, and both one industry cannot stand alone. So the other industry should support that. So he should sell what he has to sell, what he produces. Otherwise he will not be his agenda or priority for them. So then we are reviewing our quality parameters, internal sourcing quality parameters, what we call it, right? There are FT parameters and there are sourcing quality parameters. When the material or FT is coming into the factories, we have to change. Now we are reviewing all the parameters which we have in the receiving ends, right? That has to be changed. Other thing, the challenge is when we are putting it into the, for example, I have a reason, but I will not mention the brand. We change some recyclable laminates. The challenge is when you are putting it in the tray, people are, these sachets are hands. They put it in the hands. Then when the trader or the retailer, when he tries to tear it, entire thing breaks. So the strength is very much, because the usability and how it happened in the trade, that is a very much challenge. The retailer will not, he is not willing to sell it in putting it in the cupboard or something. For example, sunlight sachet or something, he always try to put it in the something in the road or in the bar in his shop. So that's a challenge for us, because Because other competitors putting in the road. So market visibility, when the somebody, the marketing concepts also there. So we have a separate ways of displaying product. The people will buy what they see. We cannot keep the product in the underneath of the cupboard and we cannot sell it. When you put it in because of we are using the recycled material, the Mudalali cannot tear it, the entire thing collapse. So we put few product, most of the thing return back to the back into the factories. Because it's not being possible. So there are huge challenge for us, and the most of the industries and the professionals, we have huge challenge for this with respect to what you answer. So how to make it convenient for the consumer, retailer, trade, wholesale. There's a huge challenge on this. But people will not accept as it is. He will not take that the recyclable thing, whatever he doesn't want. He want to put in the bag and he will sell it. That's the challenge for us right now. And you got the point right here. So all the thing, there's a one link which is into the consumer.
Just adding one thing I forgot, we have another separate R&D lab, all the recycling. We are testing MFI, we are testing impact strength, we have separate injection molding machine, produce dumbbells, impact strength, and then the elongations, all the properties we are measuring. And another one concept we are using is we are homogenizing. When we are receiving the badges, we are homogenizing. Say for example, then the verse is also there and the fresh one is also there, like that. These kind of methods we are using to enhance.
So maybe.
Yes, you can.
Maybe another part, good question. Maybe in waste management perspective, if you really go into circular economy principles, we have the last part in circular economy is useful application of material. When it comes to that part, recycling and recovery is coming into that. Of course, let them do a lot of recycling. Of course, it has numbers. We call it recyclability. It goes on. Some point of time, your material getting into a different phase, etc. So there is another part of waste management is recoveries. Like it could be we call it an RDF, residual derived fuel in cement kiln. And also now the newest concept is this concept called pyrolysis. You burn it, collects oxygen, and you get oil, something like that. But I'm not promoting that. But recyclability, recycling is better than that. But remember that in circular economy principle, recycling is not circular economy driven concept. In circular economy principle, recycling is the latter part. You have 10 hours, you have we call it a smart use and production. Refuse, reject, and then we have alternative application like where you have repair, repurpose, something like that. There are another 5 hours coming in there. So to answer your good question, but there is a limit for recyclability. In that case, we have to go to another vertical.
Thank you very much. You also have a question. Please kindly.
My question is for Inaugural. You told us that you're having online monitoring system for the energy, water, and everything. So, in my point of view is, when it's come to monitoring to the A to grade, it's kind of difficult, the traceability for that is difficult because you are having a vast supply chain. So, it will be a very difficult point for you. So, what are the actions and what are the key points that you are doing for the A to grade traceability?
So basically, in supply chain point of view, so we country level and global level we measure how much plastic we distributed. If you ask me the numbers, right now I don't have the numbers, but we know how much plastic we dispose. And all the thing, when we are buying proper plastic, we know globally what is the level of plastic you buy, and there's a clear-cut reduction plan for that. Right? So in the country level, that is tracked, right? So for example, each brand, which is the consumption. For example, SLDB sunlight powder, this is the consumption, and this is likewise we are measuring each and country level. There are one separate unit and separate team continuously. It is not a one function, it's a cross-functional part where the brand is sitting, supply chain, and from the supply chain, manufacturing, R&D, and the finance, because finance team also sitting that because finally it has to be viable, right? In the business case, whatever it is a viable one also. So we are sitting together and we are evaluating what will be the total measurement with respect to our generation and what is our collection. So how far we are collected from the market and what is the process and likewise. Especially with respect to the sustainability will not come only to the plastic, it will come only to the energy, how you measure the energy, especially that thing I measure with respect to the energy, where we are using modern analytic tools to measure the energy consumption in the factories to reduce to improve the overall efficiency with that. So plastic thing we don't have any AI model or something, but we are using a separate statistic tool to analyze what will be the consumption, what will be how the trade it has been handled. For example, we having a separate trade team in the each area. They know what will be how it will handle in the primary locations and the secondary location. Secondary mean the primary mean our warehouses and those things, and the secondary mean our distributors, and the tertiary. Tertiary in the sense basically where it is happening in the retail market. Retail market is a different scenario. So we have a separate sales team, we have separate merchandisers. So they go to each and every shelf, and if there is any deviation, they refer to the distributor point, we collect all the data. So something like that we are doing. And the car itself, there are two types of trades. One is the GT, general trade, where we are operating in the normal shop, and another one is modern trade. In the modern trade, our visibility is very much high. In the food cities, we can see how we can, people are putting out separate collection bins and we collected. That kind of things are ongoing, but it is not to the, it has to be pulled further and continuous journeys.
Especially for the CO emissions and
Sorry?
for the CO emissions, when I help with the GHG emissions, so the transport also you have to consider.
Yeah, so basically global logistic numbers we are driving. So when we do the lecturing, I can show you. The global level we measure what will be the, so we call it scope 2 emission, right? Scope 2 or scope 3, scope 2 I think. Scope 2 emission, so we measure, we have a scope 2 measurement. So we measure in that also, what will be the country level and global level emission with respect to the logistic part. So we have a few countries, for UK we have introduced the hybrid vehicle for the logistic purposes also. So the electric vehicles, some distribution, but in Sri Lankan context, electric vehicle for the transportation lorries and very much costly. So that is right now it's not viable for Sri Lanka, but definitely with the in future it will be one of the trend for us. But it is one of the major priority for us. It's a logistic.
Thank you very much. If you have a question, okay, you have. Please ask.
My question is, what is the mentality of our people from all parts of our country towards the sustainable growth? How about the support we receive and awareness about the sustainable development? Like the mentality of our people for the sustainable development.
I think Dr. Sajid can, but I have a quick answer actually. For the sustainable procurements, we have a policy in the government to promote in the national level. Right, Dr. Sajid can answer
We have about 86 national policies, and we were the first country in the world to have a sustainable select committee in the parliament and a specific national act as well for sustainability. Those are documents. Right, your question was more specific about how we feel and how we do. Right. Yeah, that's a difficult. That's not difficult. I suppose you all know the answer in a way, right? When we have a certain conditions of living, say your immediate priorities or immediate problems are so severe, sustainability is not the most important aspect of your mindset. I mean, like, you're not thinking about sustainability because you are trying to, you have one more burning issues. And I suppose Sri Lanka right now that we have those burning issues quite a lot, and I'm not sure about sustainability being addressed at the top. I mean, it's not in the top of the mind, for sure, right? But I mean, that's what I feel. Say waste management, for instance. I mean, forget about the broader sustainability. How much of times we have tried in this waste management to get to certain waste segregation, recycling, and so on, and we are not making traction. And you always find in a society it has to be done with maybe depending on the economic activity. I mean, like, you remember situations like you have seen sociology studies that have gone. The adult is not really keen to recycle, but you find the child who is going to the education and seeing some of these new developments with their education input, the child is much more responsive, right? So you find the generation aspect also coming in because they learn, listen, hear and see. Whereas the adult has gone through a very different way of living, so it's very difficult to train yourself for that. But again, in that we are now probably facing a problem because even for the child, the burning issues are, I mean, like, different things have become burning issues, and I'm not sure the education, we are not fully supporting getting the sustainability stuff in. Even though the education has a lot of elements, I mean, even frugal, I mean, like electricity consumption studies, how to save at home. There are elements in the education curriculum to do that, and workbooks as well in the government curriculum. Answer is, yeah, we are failing short of, I mean, we are well short of what we should be having. That's my view. Lot to improve.
A little bit adding to your question, we are trying to do that change, honestly, few people, hospital, Phoenix, Unilever, we are trying to do that change. We know that definitely there's a big gap. Where we see in other countries and Sri Lanka, definitely as Professor Ajit, the priorities are different as they. But school, we believe that we have to get the school level children when they come to our responsible age, then we can have a better society. So we are attacking the school children at this moment, most probably. So one day, yes, we have to come.
Yeah, I think that could be. So basically, each and everything become a priority when the leadership take these steps. Right? So in country level, organizational level, whatever, right? So that's how it happened. Right? So for example, since I have been in India for 15 years, so everything becomes a priority when the top leadership take as an initiative and it has been set as a target and it has a clear direction, then people are working on it. But to make the, I mean with respect to the organization, right? So to make a organization strategic level alignment or the direction, it will happen when the consumers are becoming much more attentive to that. Then they will understand this is the priority and this is the agenda for the consumers, and consumers are seeking for that. Then they will understand. To make the local companies or the companies to make more sensitive on this issue, the consumers should have a very much high right to ask for that. Then the people put more and more effort to improve the sustainability agenda, and otherwise it will not be. So everyone in here in this room have a huge responsibility to ask for the sustainability product from the companies, then they will make it as a priority.
Thank you, answer.
That's the type of question that probably in a master's, where you can drive that into much more quantified ways of change. How do you bring that change? Right now, even in the crisis, now we are facing an economic crisis. Probably some of the decisions that we can make at this time, maybe we should not be thinking like, okay, now the fuel is back on the tap, that we are okay. I don't think that's the way we should have acted. We should have been looking at differently now. When the Japanese had that issue with the Fukushima, they switched off nuclear power. Even though they had other nuclear power, they switched off and turned to things like wood pellet. They really started a biomass pellet international supply chain mechanism. Right? Now Sri Lanka has an opportunity with the biomass. We almost declared forest plantation wrong. So we should have gone for like forest, but the technology addition, not like convenience world that we should try and we should work on it. But we are going back to the normal. Normally this is the early format. So if a crisis sometimes can make you stronger to take some of the difficult steps, we have the right steps to suit the future. But that also doesn't seem to be happening. But these are good opportunities to make use of, to switch into a different way. Hopefully, but that's the type of thinking that we should be asking, yes, how do we bring those changes, because we have an opportunity.
So since reminded of the recession or the conflict situation that we have right now, sometimes it will give a good benefit and it will give a inverse effect for the organization also. Because the organization now going back to the look at their cost structures, right? Because of the so much of raw material prices has gone up and so much of energy, because government increased the energy prices. Now everyone look at how my efficiencies are to improve. So there are a lot of inefficiencies in the organizations, right? They run whatever they want. So since of the now they have to pay for that. Now they are look at and see how my cost structures be, especially the energy cost. So a lot of energy audits are happening in the organization, and they look at their packing material. Sometimes earlier we check how to reduce 1 millimeter from the soap wrapping. Right? We reduce 1 millimeter of soap wrapping, nobody will feel it. The huge saving. Sunlight 1 millimeter saving is huge saving for the organization. Earlier we have because it's not a bio. Now this economic crisis itself give organization to look at their cost structures and go for some kind of sustainable approaches. For example, in the soap wrapping we have removed the PET layer on the wrapper. Earlier there was a PET layer, so you will not feel there's a PET layer which will give good air barriers. But for the now consumer, that is not required right now, because the context you have to understand. So the organization will adapt for that. So there are a huge opportunity for the organization and the professional. So your value is very much high right now. You can go to the industry and you can identify opportunities, especially with respect to sustainable approaches, energy, and industry is seeking help now. Because we interacted with Dr. Santa and we are in huge opportunities. The factories are running, they don't aware of that. So now we are seeking opportunities. This is the time that we have to rise up. So actually, we respect that still our intellectuals are with us, good intellectuals are with us to save the industry. Going away from the country is the easiest. But still people are in Sri Lanka and they are protecting industries for the future generation. Right? So it is high time for you all to rise up as a nation and understand the opportunity, give the real solution to the industries. So if it is viable solution, definitely this time they will do it. Because this is the time for the industries which is hugely struggling. So local industries are hugely struggling. I know a lot of factories are closed down. A lot of factories, local manufacturers cannot survive right now. Since we are multinational, we are surviving. So because in Sri Lanka having problem, so any other country can manage the global context. That somehow we can navigate. But we know so much of small companies closed down because they don't have the expertise. They don't know what to do, how to navigate this channel. So you are the people who should support this industry. That is the requirement for the right now. Your knowledge is highly required for the counter advice. It's purely required.
Thank you very much. I think very valuable discussion. Do you have any questions further? If not, shall we conclude the panel discussion? Okay. Thank you very much. Then I conclude the panel discussion.
Thank you, sir, for the very interesting panel discussion.
to extend the gratitude to the panel members for sharing their knowledge, experience, and enlightenment with us. We invite Professor P.G. Ratnasri to hand over the token of appreciation to Senior Professor Ajit D. Alvis, the keynote speaker at the inaugural ceremony.
Thank you, sir. We invite you, sir, Professor Shanta Amarasinghe, hand over the token of appreciation to Mr. Sanjeeva Cholakumara, guest of honor at this inaugural ceremony.
Thank you, sir. We invite Professor M. Narayana to hand over the token of appreciation to Mr. Priyanjit Pereira, a guest of honor at this inaugural ceremony.
Thank you, sir. We invite Dr. Tushar Subasinghe to hand over the token of appreciation to Mr. Indigo Kumara, a guest of honor at this inaugural ceremony.
Thank you, sir. At last, we invite Dr. M. Ratnayakar to hand over the token of appreciation to Professor P.G. Ratnasiri, the moderator of the panel discussion.
Thank you, sir, for joining with handing over the tokens of appreciation.
Every successful event has a dedicated organizing committee as well as a generous sponsor. The sole sponsor for today's event is Fantasy Solutions Private Limited, number 28, Mahanama Road, Panandur.
Fantasy is an engineering solutions provider catering a broad spectrum of requirements in diverse multidisciplinary knowledge sectors including but not limited to science and technology, engineering, manufacturing, energy, architecture, medicine, pharmaceuticals, social sciences, environmental sciences, natural sciences, economics and accountants. Especially, Panacea is the sole agent in Sri Lanka for SIMA Pro life cycle assessment software.
Ladies and gentlemen, let's watch a brief video about our sponsor today, Fantasy Solutions Private Limited.
for your attention. Next, we invite Dr. M. Ratnayaka, Course Coordinator, MSc PG Diploma in Sustainable Process Engineering, to introduce the lecture panel and brief guideline for the commencement of Semester 1 academic activities of the degree program.
Thank you. So I know that we are 1 hour late, but of course this is also one more important part. I'll try my best to finish within 10 minutes. I want to introduce the lecture panel. This is the internal lecture panel actually. We have Senior Professor Ajit Alvis, Senior Professor, actually this may be, should be Senior Professor Padma Amarasinghe, and Professor Shanta Amarasinghe, Professor P.G. Ratnasiri, Professor M. Narayana, and Professor Manisha Gunasekara. That should be Professor Dulika Gunaratna, and Dr. Dulika Gunaratna and Dr. Tushara Subasinghe, and myself, and also Dr. Dilhara Setunga, Dr. Tarushi Kirtisinghe. So basically this is our internal lecture panel. You will meet them in different subjects, right? And we have a few visiting lecturers. Actually, we have more visiting lecturers in the coming time, but maybe these are past batch, right? Past intake. So we have Dr. Asoka Fonseca. He's Chief Operations Officer, former Chief Operations Officer, but now he's moved to another one. And we have Mrs. Gailidi Alvis, Supply Chain Consultant and Chairperson, Women in Logistics and Transport. She's also, you will meet in the Supply Chain Management, Sustainable Supply Chain Management module. And we have Dr. Desai Boteju, Senior Engineer from Norway, one of our proud product also. He is also, you will join with him for specialized areas, especially on process safety area. Also we have Mr. Indika Kumara. Here you can see he is also one of our visiting lecturer. And we have even other departments also from the same university, from electrical engineering and mechanical engineering. Whenever we need some expert areas on that, because sometimes in some modules, some subjects we have. So the electrical systems, because when you learn about energy auditing, you need to really look at the electrical systems also, not only the process systems. Of course, we can cover up steam systems and others, but electrical systems should be covered by a specialist. So we have Dr. V. Logishan from our electrical engineering department, and also Dr. J.R. Gamage for work study related, and especially on manufacturing industries. So they are the experts on that. So you will meet them in the coming time. And also we have one of the main aspect of our program is we have numerous guest lecturers. Actually these are just only the usual ones that we had in the last intake and planned for this first semester, but we have many more guest lecturers coming on. So this is one professor from India. Last time also he conducted a guest lecture, a very interactive one, online mode. He's the head and professor of the chemical engineering department in Vinit Nagpur. So he has very impressive research on especially converting agro waste to value-added products, right? Waste valorization area, right? And Dr. Vatsala Jinadasa from Norway, she's an expert researcher there. You will meet her with a guest lecture in the semester 1, right? Then Mr. Rushant Chandra Bose, he's Chief Operating Officer and Technical Director at Industrial Solutions Lanka Private Limited. He's also expert in wastewater and sludge treatment management systems, treatment systems design. So he has designed and installed several plants in Sri Lanka, so he's an expert in that area. So you will get a separate guest lecture session from him. Then few more guest lecturers, some experts in supply chain area, Dr. Nuwan Vimalana and Mr. Chandana Veerababu. So they are also, you will get one guest lecture session in the coming time. And last time we had Mr. Chanaka Mahawata from Forbes Marshall. He was the one who conducted energy audits, and you saw in the photos in our video discussing with students in different locations. So we measured the steam systems and fixed the data loggers and got the measurements and let the students to analyze that. So hopefully, I hope he's now actually in abroad, but maybe we can join him also, or sometimes a representative from Forbes Marshall for our energy audit work, right? So and few more other guest lecturers. So in the coming time you will see. So I would like to present this year, your intake, the plan actually as a, we have decided as a policy for your intake. For every semester, we will offer you supplementary sessions, because the specific specialty of this program is having supplementary sessions in addition to regular lectures. That is the part that we improve your skills and provide the required practical exposure, right? So we have every semester we will plan one online training program for you that is free of charge. We will not take any fee from you, don't worry. That is one free online training program in every semester. Then guest lecture in every subject, right? It can be foreign or local expert, hopefully a top manager, as I showed several people from the industry. And a practical workshop in every subject covering required software practice or some practical component in that subject, right? So that would be a practical workshop. That means it will be held in physical mode. That is maybe one day, right? One day, one session for every subject. And also every semester we'll have a physical industry visit, right? Last time also we managed it. Last intake we had every semester one industrial visit. So that policy we can have this time also. Then all these industry visits came up with the group-based project work. So you will have to combine into groups, and it's not just going and seeing like a movie watching to the industry, because mostly when I go with undergraduate students, they are doing it like a movie watching, right? They go and watch it and come back and forget everything. But for you, you are graduate students, so you have to work. You have to go there with an ambition, objective to learn, to do something, some analysis or something for some group project. So based on the subject or the way that we take you, it will depend the group project work. So accordingly you have to work. So that is the plan of how we deliver the supplementary sessions. This is the actually the timetable for semester 1, right? I will share all these details with you, don't worry, in the coming time. So hopefully tomorrow or day after tomorrow you will get an email from us, all these details. So this is just only the semester 1 program. Similar to this, you will get semester 2 and 3 programs also, right? So you will know what is the date that you will finish the course also accordingly, right? So I just wanted to show a sample. So like this, you can see there generally in semester 1 we are having the lectures. All these are, you can see venue is online mode actually, the Zoom platform. So we have Saturday, starting from next Saturday we will start the sessions, and we conduct these lectures through the digital platform, that is LMS system, learning management system. We have University of Moratuwa Moodle, right? So you will be enrolled to that model. I will share all the details with you, how to log in and all the credentials, everything will be given to you by Monday or Tuesday, don't worry. Then you will see what is there and what are the subjects. You can go there and then the lecturers will put the required lecture notes. You can get everything from there. That is how we do. And also almost all the continuous assessment also we conduct through that platform, right? So there you can do quizzes, submit your work, everything is possible. So that is learning management system is there. And we have Saturday and Sunday both days. I know that generally MSc students, you are professionals, you are working all 5 days, sometimes Saturday also, I don't know. And also you have families, so a lot of commitments, I know. So maybe this may be a bit tough schedule apparently, but I think you decided to do a master's by paying this course fee, by knowing that you have to put some effort, right? And also the other thing is you have spent money, so you have to take back the value from us, right? So just don't waste your money in that way, because what I see is sometimes the students, since it is online mode, maybe you will try to you will think that it will be available as recorded mode, or maybe you will think that it will be it can be studied later. So what you will do, you will put it in mute mode and you do some other work, like do some household work because it is weekend and maybe your wife or husband is asking for some work and you are doing that. So if you do that, you are wasting your money. And the other thing is, as a policy, we are not going to give you any recorded lectures, right? We are not going to give you any recorded lectures. I mean the live lectures that we have at this time. So it is your duty to attend these lectures, right, through the Zoom links that we provide. But we will provide you a lot of supportive learning materials. In those supportive learning materials, there will be a lot of recorded lectures. I mean, not the live sessions, some supportive recordings, right, and some tutorials, some examples, some lecture notes, everything will be available. So you can study them, but you really need to attend the session. Why? Because the lecture session having at this time is not purely listening to someone is speaking. Lecturers will put a lot of effort and they will come up with some kind of a group work or something. They will explain the basic theory required, fundamental, and let you to go into Zoom breakout rooms, go into groups inside and discuss, work and submit within that time, right? So as a nation, as a Sri Lankans, I think the problem that we have is we don't do the thing that we should do today, right? That is why we are here. So this program you can successfully complete if you do the thing today itself, right? So you don't have to do any extra work if you put the effort. If you attend these lecture sessions and work there, you will not get so many extra assignments, take-home assignments, lot of things to submit. Maybe some part that you have to work, maybe you will have some remaining work to submit, that may be that. If you are not able to complete those group work and activity-based things, right? So that's the thing. Sometime you may have to put, but not in that way. But if you don't attend the Zoom sessions, you will be in trouble, right? You will be in trouble because you will miss the things, and especially the continuous assessment component, right? So without the continuous assessment component, you can't go further. I mean, maybe you will have problems in passing the subject, right? So that I will share all these details with you. So this is very important. I wanted to tell to you because I observed in some of the previous master's students, they had this kind of practice. So please ensure that, I know that sometimes suddenly you may have to miss some lecture, that may be okay, but try your best because it is your money that you have put. You applied this course with some objective. So try to achieve that objective, try to get the maximum from our lecturers also, right? So like that you can see the training program for as a example, you can see that is in July 1st and 2nd. We have that in online mode, you can join that training program. And we have the workshop kind of a thing with an industrial visit that is happening for the energy audit in semester 1. And there will be one last week actually we dedicated for the physical workshop. So every subject will have, so what you have really attend in physical mode is, you have to attend these industrial visits and this simulation session, that will be definitely a physical class. So actually one Sunday and 2 weeks, right? That's all of the rest of the thing is online, right? But if you ask me that why can't you provide that also in online mode, because what I felt, because I am working with these dynamics of postgraduate programs but after taking this coordinatorship, lot of people call me and ask about the program. Most of the people ask me, can't we do it fully online mode? I said no. We will not offer you fully online. We will offer you online lectures, but there should be practical component, right? Otherwise, we are doing something, we are just talking something only, right? So you have to practice it. So we will try our best to minimize the practical, physical attendance. Why? Because we know that we are doing a sustainability related course, but you come here every week traveling, you spend petrol, fuel, and spend money on food and everything. So that is also, if we can deliver something in online mode, that is also not sustainable, right? So it is also a waste of resources, right? So that is why we will give you maximum in online mode, but don't ask us to compromise the physical component. Compromising the physical component from our side means you are compromising the quality of the course that you will get back, right? So think as professionals, you all are professionals. So I hope the rest of the time you will not give me as the coordinator, course coordinator, any stress on making the things require physical component, physical attendance into online mode, because that thing sometimes happened to me in last batch. So I had to work on that. So I must share that with you, because I don't like from your batch to happen that, right? So I hope this message understandable, but I know sometimes you may migrate, right? People have plans with migration like that. So if you migrate, that's your personal reason. Because of your personal reason, I can't compromise. We all can't compromise all of the other batch practical component, right? So if you have plans for migration, what you can do is you can give us a request, right? We have a program, the kind of a procedure in the university. You can extend your time maximum duration, right? And you can easily get the extension. Of course, you will, even you don't request any extension, you have 4 years to complete this, right? It is 1 year PG diploma program, and if you do masters, it will take 2 years with the research component. But you can, to do that, you can take 4 years, right? That is the thing here, simply, right? But if you want to extend it to 6 years, you can show evidences why I need another 2 years, and you can take it. For an example, you can show that you migrated because this reason, like that, and you can get the Senate approval from the university. There's a procedure. You can contact me. I can elaborate to you. Then you can get that. Then whenever you can come back to Sri Lanka, you can do the exams and complete, right? So that may be the thing that we will practice hereafter. So we have that physical component, and also the written exams will be in physical mode, right? Because like we can't have 100% recyclability, right? We can't have 100% online exams. You may ask why we can't offer online exams. It is unsuccessful actually. It's not sustainable. So we have to do the exam in physical mode to have the right evaluation and the reasonable assessment for you also. That will improve you. Assessment is improvement. You face for an exam means you get improved. It is not just measuring your performance. You have some improvement after the exam. If you made something wrong, you know that you made it wrong and you can correct it. That's how we learned in our time, right? I hope you also will learn in that way, right? Okay, so lecturers and resource persons for semester 1 is like this, so I will share this with you. And also we have some important course guidelines, some kind of guidelines for how to, what are the things that you should know when you submit assignments, when you face assessments. Sometimes for the continuous assessment part, we have online submissions, online work through the platform. Then there are certain tools we use, so you should know about that, how to use them. So that part I will cover with some special meeting with you through online mode. And first of all, I'll share all the documents. Then if you have doubt, I can provide some supplementary discussion, maybe 1 hour online, and elaborate you all the issues that you have in those guidelines, right? So that's the overall explanation about the course. So I welcome you all. Here we have a wide range of candidates, professionals coming from different industries this time. So I hope you can contribute, because doing an MSc part-time also means you will create a lot of networking, right? So that is the objective, another objective of having physical sessions also, right? You should know who are the people in your batch and build up connections. Sometimes maybe you will get your next employment opportunity based on your friend, from your friend in your same MSc batch. Who knows, right? So we are doing these things also in this way because of networking, right? So from the day that we were in the school, we were networking. Whenever we see an opportunity, chance, we get it. So I hope you will also build up the networking inside your batch, because you will have a lot of group work. So definitely you have to build up that networking. Then only learn from others. Another way is learning from your peers, right? So that is also another important. So we encourage that. We conduct the Zoom session, online sessions also, letting you to learn not only from the resource person and the lecturer, but also from your peers, because there are some people who engage in sustainability initiatives in their companies. Last time also we had people, I hope you saw in that video, they contributed a lot during the lecture, right? During the lecture they contribute a lot. Sometimes things that I have to explain when taking big effort, maybe some concept related to sustainability in my lectures, they contributed and helped me to explain from their company's example, right? So it's very simple. When we have application example, others can understand rather than theories and fundamentals, right? So that's the overall nature of this course. So thank you very much for spending one more time. So I will continue the vote of thanks also. So first of all, I must thank Senior Professor Ajit Dialvis for admitting my invitation as the keynote speaker and spending his invaluable time. He's a very busy person, but he spent the entire morning time with us sharing his knowledge. So thank you very much, sir, for staying with us today. It's a great honor for us. And also I must thank Mr. Sanjeev Cholakumara, Mr. Priyanjit Pereira and Mr. Indika Kumara. Just only one phone call you approved my invitation. So thank you very much for coming here. I hope everyone, even I learned a lot from your panel discussion. So that's what, every day we learn something from these activities. So thank you very much for your support. And especially I must thank head of the department, Professor Shanta Gudage. She is very flexible in doing certain things, helping me to arrange things, because I always need, when we do something, we need the head's approval for certain things. So she helped me a lot. Even though she is not here, I must thank her. And especially the advisory panel for this MSc program, Professor Shanta Amarasinghe, Professor P.G. Ratnasiri and Professor M. Narayan. So they were actually the founding coordinator is Professor Ratnasiri, and then Professor Amarasinghe, and then Professor Narayan. And also I must remember the fourth coordinator of this program is Dr. Dulika Gunaratna. She also helped a lot to improve this program. So thank you, sir, for always helping me, because all these things, they were behind me to support me and help me. And also I must thank all the candidates. Through just one email, you did payments and everything. You made it really easy this time by registering through the Google form. So whatever the technology that we extended to you, you admitted it and you responded our emails. So thank you very much for coming here today also. So I must thank all of the 2023 intake, and I warmly again welcome to this program. And last but not the least, I must thank the sponsor also. That sponsor is the life cycle assessment software provider in Sri Lanka, the sole agent. Actually, it was not, we did not ask any sponsorship, but he willingly gave the sponsorship. And I hope the promotional video that he put is also some message. He wanted to give some message to you, not rather a promotion, right, of his business. So I must thank him also, the Chief Executive Officer of that Fantasy Solutions. And also, especially, there are some people who really helped me, the non-academic staff of this department, and academic staff especially, and some few people actually, the Miss Dinusha Martinu, the course assistant, and then Mr. Chintaka Narangoda, he is the system analyst, and all other supportive non-academic staff. Everyone helped me a lot, and also some other departments, computer department is doing live streaming for us, and then some other departments provided us some infrastructure that we don't have. So everyone, I thank again. If I miss anyone, again I'm thanking to everyone. So thank you very much for having this session today, a successful session. Thank you.
Thank you, sir. It is the end of the inaugural ceremony of the 2023 intake of the MSc PG Diploma program in Sustainable Process Engineering. Please rise for the national anthem to wind up the session.
Lanka, Thank you very much to all of you. We wish you all a pleasant day and happy weekend.